Hello, welcome. So this is basically our project number one when it comes to healthcare projects, and this is for the top care hospital. And we have four files in Excel. That is, we have the lab results file, which is actually dirty. We need to clean it. We also do have the treatments, which is actually a dirty file still. We have to clean it. We still have the admissions file. It's a dirty file still. We have to clean it. And finally, we have the patients file, and we do have to clean it. The one which is actually open in my case is actually the patients file. You can check up there. So I have the patient ID, I have the age, I have the gender, I have the ethnicity, first admission rate, and the age group. So in this point, I would actually want us to do this kind of a scenario with Excel. Then I also show you how we can engage the Power BI to do the same thing. That is cleaning in Excel. And then we do the same scenario when it comes to the Power BI. So when it comes to us cleaning this kind of a file, like for example, you can check that I have a blank space here, and we do not actually want to have these blank cells. Yes, we do not actually want to have these blank cells or something that looks like an outlier, something like that. So how do we actually clean this? So I'll actually take you step by step to cleaning this data, all the way to data modeling, all the way to actually coming up with the insights. That is after doing the after coming up with the reports in the pivot tables. So we'll actually come up with the insights so that we can analyze our data. And finally, we come up with the dashboards when we use the pivot tables. So let's now clean with Excel. And on this point, before we actually proceed with cleaning, we have to convert this or create a table from this data. So to create a table, you have to click inside the data like that, hit on the keyboard Control T. So Control T is actually for the table. In my case, you'll actually check that the data has actually been selected automatically. You can check on the dancing ends there. Yes. And that's from A1 all the way to F801. And my table has headers. That's why it has actually been ticked or it has been checked. You can check that my headers here is actually the patient ID, the age, the gender, ethnicity, first admission date, age group. That's actually my headers. So what I have to do is hit OK so that the table will actually be created. That's it. Given that the table has been created, I would actually want us to address the first item, which is actually the data types. After addressing the data types, we also check on how we can address the duplicates. And then we also see how we can address the blank or the null values. Then we see how we can also address the outliers. So I want us to start with the data types. So let's actually start with the patient IDs here. Now, all this data here in the patient ID, you can actually check that they are in the general format, which is actually okay in my case. You can check all of them are actually in the general format. In this one here, it's also in the general format, which is also in the general format, which is actually okay. Gender, general format, which is also well. Ethnicity, general format. General format can be a text or a number. There's no problem with that. In this point here, for the dates, you can actually check that it's a text, and this is where the problem comes in. The dates must be actually a date. We have the option of short dates here. You can actually check. We have the option for the short dates. So what you have to do is to convert that date from the text format into actually the date format. So what you have to do, you can actually check down here, we have the text format. So these dates are actually in the text format, but you actually want it to be in the date format. So you actually have to pick this short date. So to select the whole of that column there, you just have to click on the one cell inside. That's the first cell inside the first admission date. Control Shift down arrow on the keyboard. Then after that, you have to come to this point to the home tab, number group, and hit on this down arrow. Then you pick on the short date, just like that. Now all this will be dates and not text. That's all. On this part, these ones are actually in general. So that's all. So we have actually addressed the data types. I want us to go to the second part, which is actually addressing the duplicates. So for us to actually remove the duplicates, we have to hit on Control A on the keyboard. So after clicking on any part inside the table, hit on Control A on the keyboard. You have two options. You can come to this point here inside the data tab. Then you have inside the data tab, then you have on this point here, that's for the data tools, we have what you call remove duplicates. Or you can as well come to this point here for the table design. Then we also have tools group, then remove the duplicates. You can click on it there, there's no problem. And make sure all these columns have actually been selected. Yes. So there's a reason why you should actually select all these columns, because if you actually select, let's say for example, you have actually selected the ethnicity only and all these others remain deselected. So a case like this one here where we have camper, yes, it's actually the first one there, and this camper here will actually be treated as a duplicate. This one will be treated as a duplicate. This one will also be a duplicate because the first one will actually be the unique item. So, but that's not what we actually wanted, because this one is actually a camber, but you can actually check that the full record is actually different. This one is also a camber, but the full record is actually different. So we do not actually want the duplicates when it comes to ethnicity. We actually want the duplicate when it comes to the full record. Yes. We actually want the duplicate when it comes to the full record. So for the full record, you have to tick all of them like that. Then you just have to hit on OK. So for duplicate values found and removed, 796 unique values remain. That actually means that you have 796 rows. So that's all. So that's all. Hit OK there. That's it. Now we have removed the duplicates. The next item here, the next case is for us to address the blanks or the null cells. That's the null values here. So how do we actually identify if we have the blank cells? So for the blank cells, you just have to hit on the filter button there. You can actually check that when I hover my mouse there, it is actually telling you showing all, meaning we have not actually applied the filtering. So if you click on the down arrow there and scroll up to the last item, you'll actually realize that there is no blank. If there was a blank, it could have appeared to be the last item here. You would have had blanks appearing to be the last one. But because our last item is actually P00800, then it actually means that we do not have a blank cell when it comes to the patient ID column. Let's now address the age column there. So scroll down there to actually check if we actually have a blank. We do not have a blank. So that column is actually clean. Now let's also go to the gender there. So hit like that. You can actually check that we only have two, female and male. So that's actually okay. We do not have a blank. Now let's also go to this point here for ethnicity. So it's like that. Now you can actually check that for ethnicity, we actually have a blank, which is actually here. You can actually check that it's the last item. So whenever you actually have a blank, it will actually be indicated to be the last item there inside the brackets. But in my case, if you would actually want to filter out the full record, yes, you just have to deselect like that and hit on OK. So the whole record will actually be deselected. And that actually means that that record was actually here between 17 and 19. You can actually check that row number 18 has been filtered out. So the entire record will be filtered out. It's not just the cell, it is the full record. Now you can actually check that when filtering has actually been applied, the button there changes. You can check that this one is actually different from this. Let's also address the first admission date. Click on the down button there. Then scroll down there. You can actually check that we do not have a blank. And on this part too, hit on the down arrow there. You can actually check that we do not have a blank. Now, there's something that I would actually want to tell you. When it comes to the blank cells, if you are actually dealing with the text, for example, this one here, or gender, or ethnicity, or the dates, or if you are actually dealing with the age group, then it's always better for you to filter out those rows. You deselect the blanks and that's all. But if you are actually dealing with, let's say, for example, we add cost, revenue, profit, something like that, then it is not always advisable for you to actually deselect or filter out the blank cells. No, you can just use the median to replace that blank cell in a column for the profit. So if these ones were actually for the profit and you actually find that this cell is actually blank, then instead of us actually filtering out the whole record, we can just obtain the median for this column. Then we replace that blank cell with the median. So that is when it comes to the numerical columns. That is for the cost, for the revenue, for the profit, such kinds. So we'll actually check on that when it comes to the next file. This data is actually clean. So in this point here for the age, there is something that we always call an outlier. So when it comes to the age in this point here for the data, it is always advisable that you do not actually try to identify the outliers, because it's very possible for you to actually have somebody who is actually 110 years going to the hospital, and it's also very possible for you to have somebody else who is actually 6 years going to the hospital. So the outliers do not actually work so efficiently when it comes to the age. So like in this point here, you can actually check that this person is actually 75 years old, and this one is actually 6 years old. So that does not actually mean that this one here is an outlier. No, it's actually very possible to have a child of 6 years going to the same hospital. So there's no problem there. So this data is actually clean, and because this data is actually clean, get into the next item. So we are actually done with the patient's file. So I want us to check on the admissions file. So this is it. So for the admissions, we call it the admissions underscore data file. So in this part, we have the admission ID, the patient ID, admission date, department, diagnosis, the outcome, readmission within 30 days, the cost, and the insurance type, and the discharge date. So for this part here, for the cost, yes, if a cell is actually blank, then it's not always advisable for us to filter out the entire row. You can just obtain the median for this cost column and replace this blank cell with the median. That's what I actually told you in the previous file. So before we actually start cleaning, because you can actually check that I have a blank cell here, I also have a blank cell there. So it actually means that we have to address on cleaning the data. So before we start cleaning the data, you just have to click inside the data like that. Then you hit on Ctrl T, because we would actually want to create a table. So this one is actually from A1 to J1201. So J1201 is actually our last one. My table has headers. You can actually check that I have the admission ID, patient ID, admission date, department, diagnosis, outcome, readmission within 30 days, the cost, the insurance type, and the discharge date. Just like that, and you hit on OK. So this is it. Now I would actually want us to address the first item, which is always the data types in my case. So we have to start with the data types. Then we go into checking the duplicates. Then we address the blank or the null cells or the blank cells. Then we also check if we have the outliers. Then we check if the cases are okay. Let's say, for example, the lower cases. If you would like to convert something from the lower case to the upper case or to the proper case, something like that, then our data will be clean. Or if we have an outlier, we have to replace that blank cell. If it's actually a numerical column, we replace the blank cell with the median. Let's actually address that. So for the data types, you can actually check that this is supposed to be in a general format. So I hit on the home tab there. You can actually check it's actually a general format. This one too, a general format. This one here, it's actually a general format. But in my case, I would actually want to have the admission date to be a date. So to select the whole of this column, you just have to click on the first cell inside the admission date column, hit on Ctrl Shift down arrow. The whole column will actually be selected like that. Then you come to this point here, that's inside the home tab, number group. You just have to convert that general into short date. So that's all. In this point for cardiology, that's for the department. You can actually check that they're in general format, which is actually okay. This should be in a general format, 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 and this one should actually be a date. So what you have to do is to click on the first date when it comes to the discharge date column there. Ctrl Shift down arrow key, then come to this point here. That's inside the home tab, number group. Click on this down arrow and then hit on short date, just like that. So for the data types, everything is okay. I want us to check on the duplicates. So to check if we have the duplicates, what you have to do is to click inside the table like that. So after clicking inside the table, we have to hit on Ctrl A to select everything there. Then you can actually do this in two ways. You can come to the data tab there. Then inside the data tab, we have what you call data tools group, then remove duplicates. You can also come to this point here for the table design tab. Then inside the tools group, we have what you call remove duplicates. You can hit on it like that. Then make sure all these columns have actually been selected. That's what I actually told you before. And hit on OK there. it will actually tell you 6 duplicate values found and removed. 1194 unique values remain. That's okay. Yeah. Now the next item is for us to actually check on the cases. So let's now address the blank cells. So you can actually check that I have a blank there. There are actually many. If you would actually want to identify them, then click on one of the cells inside the table, hit on Ctrl A on the keyboard, then get yourself to the home tab, conditional formatting there inside the styles group. Then you have what you call the new role. Then in this point, you can actually pick only cells or format only cells that contain in this part, hit on the blanks, and we can give a red fill formatting. Just like that. Okay. Okay, again, now you can actually check that you have a blank there. We have a blank here. If you scroll down, you might also get another blank. Yes. So scrolling down might actually take some time, but you can actually check. We have some here. But if you would like to identify the total blank spaces that or the total blank cells that we do have, we can just hit on using the count blank function. So remember, the name of our table here is what you call table 1. So you can actually use the count blank function so that we can count the number of blank cells that we have in our table. Our table name is actually table 1. So it's equivalent to count blank. Like that, you open, it will ask you for the range. So in this point, I'm actually using my table 1. So just like that, and you'll actually check that the whole table will be selected. Hit enter on the keyboard, 8 blank cells. So we have a total of 8 blank cells, and we would actually want to address them one by one. So in this part here, what you have to do, because you can actually check that for the departments, these ones are actually the text. So we can just filter them out. That is, we filter the entire rows where one of the cells is actually blank. So you can actually check that in this row, one of the cells is actually blank. So you have to filter out the entire row. Click on this down arrow there, scroll down. For the blanks, it must always appear to be the last item, like in this point here. So deselect it, then hit on OK. Now you can actually check that we have 12, then 14. So 13 has been filtered out. You will realize that in this point here, this 8 is not actually shifting to 7 because already we have actually removed one of the blank spaces, because it still identifies the hidden row or the filtered out row. So that's why it's actually still 8. It still identifies the filtered out row. So there's no problem with that. So let's also come to this point here for the diagnosis. You can actually check that the filter icon here and here are actually different, because in this point we have already done our filtering. That is, does not equal blanks. Let's now come to the diagnosis part there, and you can actually check down there. You will actually see that we do not have the blanks, meaning that we do not have a blank cell there. So do not actually waste your time. Get yourself into the outcome column again there. Click on the down arrow. You can actually check that we do not have the blanks. So do not waste your time. Hit on OK there. Run fast. Come to this point here. We do not have the blanks again. Everything is okay. In this point here, we actually do have the blanks. Yes, we do have the blanks. But because it's actually for the cost column, then instead of us actually filtering out those blanks, we can just obtain the median for all these items. Then we replace that blank with the median. It's actually very simple. So before we actually come on that, let's actually come to this point here. We finish with the filtering out, because this one is actually a text and this one is also a date. So let's actually have this one to be our last item. So let's come to this point here for the insurance type. In this point, you can actually check that we do not have the blanks. Everything is okay. In this point too, click on the down arrow there and scroll down there for the dates, and you will also realize that we do not have the blanks. So that said and done, I would actually want us to address the cost. So for the cost, we can actually replace this blank with a median. And there are actually 2 ways of doing that. You can actually use the if plus the is blank and the median in one formula. That is, you use the if function so that a cell which is actually blank will actually be replaced by the median. And to identify the blank cells, you have to apply the is blank function. And to also come up or calculate the median, you also use the median function. So it's actually the if function, is blank function, and the median function. Let's actually see how the three can actually be incorporated so that it can actually come up with the result. So it's equivalent to if. In all the cases where you have to use the if function, then the if must always be the first one. So if the cell is actually blank, and to identify the blank cells, we actually use the is blank. So if the cell is blank, that is this cell. If the cell in H2 is blank, then get me the median. What is the median? For the median, we do not know. So we have to use the median function to calculate the median. So you select everything there. So select up to the last item. So let's actually go down there up to the last item. So you can actually check that that's our last item. So it's actually table 1, which is actually our table, and this is actually the cost column, which is actually okay. You just have to close. So you close the median function. So if a cell is blank, or if this cell here H2 is actually blank, this H2 will actually be shifting because it's not actually absolute, it's relative. It will be changing to H3, H4, H5. So if, for example, H2 is actually blank, then get me the median. Replace that blank cell with the median. Otherwise, if it's not blank, then get me the same value for H2. That is, if this cell is actually blank, then calculate the median and replace that blank cell with the median. But if it's not actually blank, then retain 3716. That is, you retain 3716. Don't do anything with it. So you close the if function like that. Hit enter on the keyboard. Now you can actually check that it's getting me 3716. Why? Because that cell is not actually blank. We actually say that if it's not blank, then you retain the H2, which is actually 3716. So allow me in this point here to actually drag to this part, because that's where we have the blank, and see what will actually happen. So in this point, let's actually see. Now you can actually check that this blank cell here has actually been replaced with 44 to 58. That's it. So 44 to 58. So you can have this running all the way up to the last cell down there. Yes. But allow me to also show you how we can use the median function so that we can actually come up with the median. This one is always very quick. So for the median function, we'll actually say is equivalent to median, just like that. Then we actually open it. So it will ask you for the range. In my case, I'm actually dealing with table 1, and inside table 1, I'm actually dealing with the cost. So square bracket, then cost, like that. Then you can just double click on this point there. Then you close the cost. Then you close the bracket there for the median function. So this is basically saying in my table here, which is actually table 1, that's actually the name of my table. In table 1, I'm actually doing the median for the cost column. Yes, that's it. So the moment I hit enter there, you can actually realize that my median is 44 to 58. What did we add here? Because this is where we add the blank, 44 to 58. So after identifying the median to be 44 to 58, what we can actually do in this point is do the replacement. Yes, we can actually do the replacement. How? We can say in a point where we have the blank cells in this column, then replace those blank cells with 44 to 58, because 44 to 58 is basically the median. Yes, so you select the whole of that column like that. Then you hit Ctrl H on the keyboard. After hitting Ctrl H on the keyboard, you have to find the blank. Then you replace that blank with 44 to 58. So find the blank. So for the blank, we won't actually write anything. Replacing with 44 to 58, just like that. So this red one here will actually be changed to 44 to 58, and this red field here will actually disappear, because this red field was actually for the cells which were actually blank. So after replacing this blank cell with 44 to 58, it actually means that it's not blank anymore. So this red field here for the conditional formatting will disappear. Let's actually see what happens. So replace all. Now you can actually check that we have made 11 replacements. So all done. That's it. And okay, now you can actually check that we have 44 to 58, and the red field formatting, that's for the conditional formatting, has actually disappeared. That's all. So allow me to actually remove this like that. Then you just have to select there, hit on right clicking, then clear the contents there. So everything is actually done for the cost column. So for the cost column, we actually replace the blank cells with the median. So I would also want us to identify if we actually do have the outliers. So for the outliers, outlier is a number that's actually or a value that's actually too far away from the range. Let's say, for example, if you are actually in a class and the students have actually scored 10, 15, 20, 18, 17, 12, and one of the students has actually hit 78, then that 78 is actually an outlier. It's too far away from the range. So how do we actually try to test if we have the outlier? Because for the outliers, it actually affects the numerical columns only. So this is it. That's the cost column. So I would actually want us to check if we have an outlier when it comes to the cost column. So for the outlier, you have to calculate the quarter one, which is always the 25th percentile. You also have to calculate quarter three, which is actually the 75th percentile. And you also have to obtain the interquartile range so that you can subtract and give some allowance and now try to identify if we have the values falling out from the allowance. So let's actually check. So we have already said that you have to obtain quarter one, you also have to obtain quarter three, and you have to obtain the IQR, which is actually the interquartile range. Then we can now start. So for the quarter one, in Excel, you have to use the quartile .inc. Then you open. That's what you actually use to obtain the quartiles. So I'll actually hit on click on the first cell there, Control Shift down arrow, then it will actually select everything there. Then let's actually go back and you can actually check that it's actually for the cost. Now you can actually type table one, which is actually the name of my table here, square bracket cost. Cost is actually the column. So that column is actually inside the square brackets. Then you actually have a comma. That comma is actually to indicate that we are running the first quartile, and the first quartile is always the 25th percentile. So you double click on it like that, which is actually 1, close it, enter on the keyboard, which is actually 23,816. So on this point here for quartile 3, we can also do the same thing. That's quartile.inc. Then you actually open. It will ask you for the array. For the array, because this is actually table 1, the name of my table is actually table 1, and we are actually interested with the cost column. So we can actually write table 1, table just like that, and you double click on this one here, square bracket cost, double click on this one here, then finally a square bracket to close, then a comma. Have it as quartile 3, which is actually the 75th percentile, because you are dealing with Q3, quartile 3, that quartile 75th percentile. Double click on it like that, then you close, then you hit enter on the keyboard. Now you can actually check that that is quartile 3. So this is quartile 3 and this is quartile 1. So how do we always calculate the interquartile range? The interquartile range is always equivalent to quartile 3 minus quartile 1. Just like that, hit enter on the keyboard. We have 39, 6, 33, 39, 6, 33. So I would actually want us to obtain the upper limit and the lower limit, UL and LL. UL is also known as the upper boundary, and this one down here, lower limit, is also known as the lower boundary, LB. So how do we actually calculate the upper limit or the upper boundary? Now, given that you are actually in a class and the students have actually scored 10, 12, 17, 18, 23, 18, 12, something like that, 78. Now, and in this point here, you actually want to run the interquartile range. So how do we actually obtain the upper limit or the upper boundary? So the upper boundary is actually equivalent to quartile 3 plus some allowance. So which is actually, quartile 3 is actually on top, then you give some allowance. So to give some allowance, you can actually say plus, then then open a bracket, then you say 2 plus the interquartile range, and the interquartile range is actually on M4, just like that. So this M2 is actually the quartile 3, then we are actually giving the allowance on top. So if your quartile, if your Q3 was actually equivalent to 23, then we are actually saying 23 plus some allowance. Let's say that allowance will actually shift us to 40. So anything that is above 40 will actually be an outlier. So that's it. So I always use these two as a standard figures. So it's actually M2, which is actually Q3. Yes. So Q3 plus some allowance. So allowance is actually 2, then you multiply it by the IQR, which is actually the interquartile range, and it's actually on M4. So this M2 is actually 63,449 plus some allowance. allowance you can give by using 2, or you can give by using 1.5 or 1.8. In my case, I always prefer using 2. So 2 times the M4, which is actually IQR. That one will actually be 142,715. So any value which is actually above this one will actually be treated as an outlier. Yes. So my Q3 was actually equivalent to 63,449, but I'm giving some allowance so that any value which is actually above this 142,715 will actually be treated as an outlier. So let's also come down here and give for the lower limit or the lower boundary. So for the lower boundary, we actually do the same thing, which is actually equivalent to Q1. Now, in this point here, because we are actually giving some allowance to the bottom or some allowance down there, then we'll actually say minus. Remember, in this point here, we were actually saying plus so that we can give a range going up. But in this point here, we are giving a range going down. So it will be minus. That actually means that we'll have to get a value less than 23,816. So minus, then open the bracket, 2 times the IQR. Then the IQR is actually on M4. Just like that, you close it, enter on the keyboard. Now you can actually check that I have my upper boundary to be 142,715 and my lower boundary to be negative 55,450. So if we have a cost going beyond 142,715, yes, then that one will be an outlier. If we have a cost which is actually negative 55,450, then that one will be an outlier. But in this case, obviously, we do not have the negative values. That actually means that the outlier will actually run for the positive values only, which is actually 142,715. So a cost higher than 142,715 will be an outlier in my case. And what do we actually have to do? We have to replace that outlier with the median. So let's actually try to see if we have the outliers. So to identify the outliers, what you have to do is to use the OR function. So we have to use the OR function. So what you have to do is to select all the items inside the cost column. So you click on the first item, hit on Control Shift down arrow key to select the entire column. Then what you have to do next is to get yourself into the home tab there, styles group, click on conditional formatting. Then on this part here, we have the new role. Then inside the new rule there, we also have use a formula to determine the cells to format. So we are basically using the OR function. So OR like that. Yes, that is if this cell here, yes, and we have to remove this $sign before 2 because we would actually want that H2 to change to H3 to H4 to H5, H6. So if you lock that 2, then it actually means that it won't be shifting. So this $sign here before H is because we are still on the same column H. There's no impact there. So if it's actually greater than the upper boundary or the upper limit there, which is actually on M6, there's no problem because it's actually locked because which is actually M6, comma, or the same H2, which is actually this one here. So you remove the $sign before 2. Remove the $sign before 2. If the same H2 is actually less than the lower limit or the lower boundary, then give a red fill formatting. So I'll actually close it and explain it again. So this OR function is always used for running 2 conditions or 2 plus conditions. So if one of the conditions is actually true, then it will always output a yes. So it actually needs one condition. Condition 1 is if this 3716 is actually greater than 142,715. Condition 2 is if that is 716 is actually less than negative 55,450. So if those conditions are actually met, that is if one of the conditions is actually met, then the formatting will actually be a red fill. So you click on the fill so that you can get these background colors. Select the red color there. That's what I always prefer because it's actually catching to the eye. Then I hit on OK here. Now you can actually check that we have one of them here, which is actually 156, 150. And I don't know if we have others down there. So what you have to do, because we do not actually know if we have others down there, so what we have to do is to use the count ifs function. So in this point, we actually have 2 conditions. If it's actually greater than this one here, or if it's actually lower than this one here. But in my case, all of them are actually positive. So we can actually use the count if function, or we can actually use the count ifs function. Count if function because all of them are positive, or you can use the count ifs function because of the 2 conditions. let me actually show you how the two can actually be done. So in this point, I'll actually say greater than 142,715. On this part, it should be less than negative 55,450. So any value greater than 142,715 or less than negative 55,450 will be treated as an outlier. So we would actually want to count the number of outliers that we have. So we have 156, 150. So it's equivalent to count if. So we can actually use the count if because we are actually basically interested with the first condition, which is actually 142,750. We do not have the negative. We do not actually have the negative items when it comes to the cost. Or we can just run the count ifs because of the two conditions. There's no problem. We can use the one condition 142,715, or we use the two conditions 142,715 and negative 55,450. So if we use one condition, it will be count if. If we use the two conditions, it will be count ifs. So let's use the first condition, 1. Count if like that. So we are basically counting if the whole of this range, and that range is basically inside the table 1 column, inside the table 1 table. So table 1 like that, opening square bracket, cost, closing square bracket, then comma. Then the criteria in this point is actually greater than 142,715. Just like that, I close it, enter on the keyboard. Now you can actually check that I have two items inside the cost column which are actually greater than 142,715. So basically, I have this one here and another one which I do not actually know. So it's basically equivalent to 2. So the outliers are 2, and you can actually click on the down arrow inside the cost column there, and you will identify that down there because this one here for the cost, or when it's actually a numerical column, it will always be in an ascending order. That's actually from the smallest down there to the largest. So you can actually check that I have 156, 150. Then it actually means because they are 2, it will be 156, 150 and 161, 897. So how do we actually clean those outliers? Yes. So to clean the outliers, remember we had actually calculated the median before, and we actually identified the median to be 44,258. So I want us to clean the outliers. So we will be replacing 156, 150, yes, and 160 what, and 161. I can actually show you, and 161, 897 with the median. So I want us to replace 156, 150 with 44,258. Very simple. Select the column like that, hit Ctrl H on the keyboard. Then we are basically finding 156, 150 and replacing it with 42 and replacing it with 44,258, which is actually here 44,258. So replace all like that, and one replacement has been made. You can actually check that one replacement has actually been made. This one here. So we can come to this point again. Now you can actually check that the number of outliers is actually decreasing. Now we have 1. So let's now clean that one so that it can actually become 0. So click on the down arrow there. That's the button for filtering. And what remains is actually 161, 897. So 161, 897. Just like that. And 161, 897. Now replace all, and one replacement has been done. Now you can actually check that the number of outliers is basically equivalent to 0. So our data is now clean. Yes, and I hope you have actually understood everything there. I want us to also check on the next case. So allow me to actually clean that. Then after that one has actually been cleaned, then you can remove the impact of the conditional formatting. So get yourself to the home tab there. Inside the home tab, we have this point. Then you can just clear the rules or clear from the entire sheet. That's it. So no outliers, everything is okay. Now I want us to address on the second last file. So for the second last file, this is it. And there is nothing too much here. So we'll first create a table. So hit on Ctrl T to create a table. So this is actually my table. The range has been selected and my table has headers. It has actually been checked. Okay. Then double click to out of it. Double click on the column headers there. Double click on this point again. double click it there, then you also double click it there. So this part here, we can actually start with the data types. So for the data types, we are actually trying to check if they are actually in the correct data type. This one should actually be in general format because it's actually a text. General format again. This one should also be in a general format. This one should also be in a general format. And this one should actually be in a date format. So you can actually check that it's in a text format, so you have to clean. Make sure you actually address these dates because it will give you problems if you do not clean them the way they should be. So click on the first date there, Control Shift down arrow key, then change from text to short date, just like that. So on this part, allow me to actually check if we have a blank. No blank, very plain, that one. This one here, let's actually check down there, very plain, that one, no blanks. This one here, let's actually check if we have the blanks. We actually have the blanks. So what we have to do in this point is to actually deselect so that it can be filtered out. So hit on OK. That's actually done. On this point, now you can actually check that the button there has actually changed. On this point for the procedure, you can actually click on it like that. Then scroll down there to actually check if you have the blanks. You can actually check that you have the blanks. Deselect it like that. Then you hit on OK. That's all. So in this point, you will also realize that we have the names for the doctors here. So if I can scroll on them, you will actually realize that we have Akenye, which is actually on a proper case, Chebet, proper case, Kamau, proper case, Mutua, proper case, Mwangi, proper case, Omodu, proper case, Wanjiku is actually in the lowercase. That W for Wanjiku is actually in a lowercase. So what you have to do is to change that W in lowercase to W in uppercase. So Control H on the keyboard. What are we replacing? We are replacing Wanjiku with Wanjiku in capital W. Just like that. Replace all. We have made 346 replacements. Bam. Just like that. And everything here is done. That was actually quite easy. Finally, I would actually want us to check if we have the duplicates. So hit Control A, then get yourself to the table design there, tools group, remove duplicates. Let's try to see, make sure all these columns have actually been picked, then hit on OK. We have 7 duplicate values found and removed. 24 and 3 unique values remain. Okay, done. So what actually remains is the last file, which is actually for the lab results. So double click to autofit. Double click there, double click so that you can actually check the results well. Then that's it. Now you can actually check that you have the lab ID, patient ID, test type, result, lab date. So we have to clean because you can actually check that you have the blank spaces here. This date is actually in a general format. We can clean. Hit Ctrl T on the keyboard. After hitting Ctrl T, my range has already been selected. My table has a dash, which is actually okay. Hit on OK there. That's all. So let's first start with the data types. So in this part, this one should actually be in general. This one here, general. This one here should also be in general. General again. This one is actually general, and this one should actually be a date. So Control Shift down arrow key and change that general to short date. Very simple. Done for the data types. Let's now check if we have the duplicates. Click inside the table, Control A. After hitting Control A there, table design, or you can actually use the data tab there. Then inside the data tab, we have what you call the data tools group. Hit on remove duplicates there. Make sure all these columns have actually been selected. Hit on OK. 14 duplicate values found and removed. 5,000 unique values remain. Okay. After the duplicates, I want us to address the blanks or the null values. So on this part here, we click on the down arrow there for the filter icon. Now you can actually check that in this part we do not have the blanks. Very clean. Patient ID. Scroll down there. We have a blank, but because it's actually for the patient ID, we can filter out the entire row. In this part here, for the test type, let's actually scroll down there. You can actually check that we have a blank. Deselect the blank, filter out the entire rows, just like that. For the lab dates, I want us to skip the result first. For the lab date, you can actually check that we do not have the blanks. Now, when it comes to the results, I would actually want us to check if we have the blanks, because in this point here, now you can actually check that we have the blanks. So we have 180, 155, 151, like that. And I would actually want us to see if we have the outliers here. So to check for the outliers, I've already shown you what we actually do. We have to run quartile 1. We also have to run quartile 3. And we also have to run the interquartile range, the IQR. So for the quartile one, we'll actually say is equivalent to quartile dot inc, like that. Then you actually open. It will ask you for the array. This is basically my, the name of my table is actually table 4. So this is basically table 4, and inside table 4, I'm actually interested with the result column, like that. I close with a square bracket, then comma, I identify the quartile, which is actually quartile 1, which is actually the 25th percentile. Double click on it, like that. You close the quartile.inc, then hit enter on the keyboard. 29.46. That's actually quartile 1. Quartile 3 is equivalent to quartile dot inc, like that. Then you actually open. It will ask you for the array, which is actually table 4, then square bracket result, square bracket to close the result, then a comma, then it's actually quartile 3, just like that. I close it, enter on the keyboard. It's actually 70. Interquartile range is actually equivalent to Q3 minus the Q1, and it will actually get me the result of 40.54. Now, what actually remains in this point is to identify the upper limit and the lower limit. The upper limit is also known as the upper boundary. Yes, a stroke, upper boundary, and the lower limit is also known as the lower boundary, just like that. So for the upper boundary, we'll actually say Q3, which is actually there 70, yes, plus we are giving the allowance going to the top. So plus open 2 times the IQR. The IQR is actually on I5. Hit enter on the keyboard, 151.08. On this point here, for the lower limit or the lower boundary, we will actually say is equivalent to Q1 minus, we are giving the allowance going downwards. So minus 2 times the IQR, which is actually 40.54 on I5. Hit enter on the keyboard, negative 51.62. So I would actually want us to use the conditional formatting so that we can highlight the cells which are actually greater than 151.08 or less than negative 51.62. So LL, which is the lower boundary, is actually, so the upper limit or the upper boundary is actually 151.08, and the lower limit or the lower boundary is actually negative 51.62. So before we actually address that, I would actually want us to address the blanks first inside the same column. So everything is actually okay here. So allow me to actually address the blanks first inside the same column, because if I click on the down button there, you'll actually realize that we do have the blanks. So allow me to address those blanks first. So for the blanks, it's always very simple. So we replace the blank with the median. So what is the median? How do we actually calculate the median? So median, like that, and open. I'm actually on table 4, and inside table 4, I'm actually interested with the result column. Just like that, I close, then I close the median function. Hit enter on the keyboard. I have 50.35. So basically, this is the median. The median is 50.35. So all the instances of a blank must be replaced with 50.35. So select the whole column like that. Hit Ctrl H on the keyboard. Then on this part, we are replacing the blank, which is actually empty there. Do not actually write anything. Then replace it with 50.35. Then replace all. We have made 17 replacements. Done. So that's all for the median. So now let's actually come to this point here. And in this point here, I would actually want us to identify the outliers. We have already given the upper limit or the upper boundary to be 151.035 and the lower limit or the lower boundary to be negative 51.5525. So I want us to use the conditional formatting to identify the cells or to give the cells a red fill formatting where these outliers actually exist. So for the conditional formatting, so we have to select, that is, you click on the first one there, Control Shift down arrow key. so that you can actually select the whole column there. Then you actually go into the home tab, conditional column there, then hit on the new rule. Then after hitting on the new rule, use a formula to determine the cells to format. On this part, we have to say is equivalent to or. Then you actually open D2. The first cell is actually on D2. So if D2 is actually greater than my upper limit or my upper boundary, comma, or the same D2 is actually less than my lower limit or lower boundary there, then you actually close the or function. Then in the formatting, I would actually want to give a red field formatting. Okay. So I have 155.18 like that. So we do not actually know the number of outliers greater than 151.02.035 and the number of outliers less than negative 51.5525. So I want us to count the number of outliers greater than 151.035. So we can click on this filter button there so that you can actually scroll down and you'll actually realize that 151.0. So we have 151.47. We also have 155.18 and we also have 180.86. So the outliers which are actually greater than the upper limit are actually 3. So let's also check the outliers which are actually less than negative 51.5525. So let's also identify the number of outliers which are actually less than negative 51.5525. So you can actually check that we have negative 69.03. This one is actually less than negative 51.5525. So that actually means we have to replace negative 69.03 with a median, and we also do have to replace the last 3, which is actually 151.47, 155.18, 180.86. So we basically have to replace those 4 items with the median. And what was actually the median? The median was equivalent to 50.35. Yes, that was actually the median. That's what we actually had there. So I can still get you the median there so that you can check it. So it's actually inside the table 4, and the column is actually result column, closing square bracket, close the median, and 50.35. So basically we will be replacing all those outliers with this 50.35. So let's first start with 180.86. So I'll actually click on the result column there, hit on Ctrl H on the keyboard, then I'm finding 180.86 and I'm trying to replace with 50.35, which is actually okay in my case. Replacements 1. It's actually done. That's it. Let's also check the next one. You can actually come to this point here, scroll down. You can actually check that I have 155.18. So 155.18. Ctrl H on the keyboard, then 155.18. Just like that, we are replacing with the median of 50.35. One replacement done. And finally, on the outliers exceeding the upper limit, we have 151.47. So Ctrl H on the keyboard. So Ctrl H on the keyboard, 151.5. That's 151.47 like that, replacing with the median. That's actually done. Then we have one of them which is actually less than the lower limit. It's actually negative 69.03. So negative 69.0. So negative 69.03, we are replacing it with the median. So negative 69.03, replace it with the median. Replace all. That's it. And okay, so at this point I can assure you that we do not have the outliers. So allow me to now erase this like that. I right click there, I clear the contents, then I get myself to the conditional formatting there, then I clear the rules inside the entire sheet. And when it comes to the test type here, you can actually check that we have test type here, you can actually check that we have blood glucose, cholesterol, hemoglobin, but we are supposed to replace this hemoglobin with hemoglobin. There should be an A in between H and E, and there should also be capital S for sodium. So capital S for sodium, and when it comes to hemoglobin, there should be an A in between H and E. So those are the two replacements that we should actually do when it comes to the test type. Then we actually clear with everything else. So selecting the entire column like that, Ctrl H on the keyboard. After hitting on Ctrl H, I'm actually replacing hemoglobin like that with hemoglobin. Yes, so I'm replacing hemoglobin with hemoglobin. So replace all 470 replacements. That's actually done. So I'm also replacing sodium, which is actually with a small s, with sodium in uppercase, just like that. That is the first with sodium in proper case, and replace all like that. 5.1 replacements done. So all our files are now clean, and what remains for us is to do the data modeling. Remember, we actually started with the patients file. We cleaned it. We came to this point here for the admissions file. We also cleaned it. But there's something small that I would actually want us to address here. When it comes to diagnosis, you can actually check that we have anemia. We should be having an A in between N and E. And we should also be having this COVID-19. This OVID should actually be in lowercase. And this heart failure, this F here should actually be in uppercase. And this M for malaria should also be in capital. That is, malaria should be in a proper case. We can start with malaria. So malaria should be in a proper case. Select the column like that. Ctrl H on the keyboard. Then we are replacing malaria with small cases, with malaria in uppercase. Just like that. Replace all 80 replacements. Done. We are also replacing COVID-19 in caps with COVID-19 in proper case. So Ctrl H again on the keyboard, and you have to erase that. Find COVID-19. Then you actually replace it with COVID-19 in proper case. Replace all 1 or 3 replacements. The other item was actually the heart failure. So for the heart failure, we have to get it in proper case. So it should be heart failure. Just like that. Replace all 1 or 6 replacements. I do not actually think there's something else to be done. So for anemia, we have to get an A in between N and E. So there should be an A in between N and E. That's all. And it will be, that's all. So anemia, find anemia like that and replace it with anemia. Replace all 112 replacements. Done. So glad for this. Now in the next video, I want us to do data modeling. Then we also see how that model will now help us to solve the many problems that we are facing, and also how that data model will actually help us come up with the insights from the data. Remember, this is just some random data, but there are no insights at the moment. So the data model will actually enable us to use the pivot table, yes, so that we can actually come up with the several insights from this data. I would actually want us to do the data modeling. So we have already cleaned our data, and I want us to create the relationship between these 4 tables. So you can actually check that these 4 tables have not been linked in any way. Yes. So these are 4 different files which have not been linked in any way. So I would actually want us to link this data so that you can so that you can actually run the different calculations. Or we can actually say we would like to see the average cost by age group. Now you can actually check that the age group column is actually inside the patients table, but the cost is actually inside the admissions table. You can actually check the cost here. So creating a model will actually help you run the calculations within the tables by using the pivot tables. So before we actually go into creating a data model, that is creating the relationships in this table here, creating a relationship between these four tables, we have to create a blank workbook. Control N on the keyboard, it will actually create a blank workbook. So after creating a blank workbook, what you have to do is to close the 4 Excel files. Remember, you cannot actually import when they are open. So you have to get back there and close. So you place the patients file, close the admissions file, close the treatments file, close the lab results file. So 4 files have actually been closed, and I would actually want us to import to this point here. So when it comes to data modeling in Excel, we do not actually run just like the normal functions that we actually do have in Excel. This one has a special tab. Like in my case here, you can actually check that we have what you call the power pivot. So this power pivot is actually for data modeling. So if you do not actually have this data modeling tool, which is actually the power pivot on your tab, then you have to do one thing. Get yourself into the file tab there. Then inside the file tab, we have what you call the options, or you click on more. Then you hit on the options. After hitting on the options, we have what you call the add-ins. You click on the add-ins, and down here, you will actually check that we have what you call the com add-ins, like that. Then I hit on go. Then it will actually bring me to this dialog box here. The add-ins available, we have the Inquire, the Microsoft Power Map for Excel. But in my case, I actually wanted the Microsoft Power Pivot for Excel, that is for data modeling. Then you hit on OK. After hitting on OK, just restart your computer or your PC, and you will see a Power Pivot tab there added. That's it. So that power pivot is what we'll actually be using to create a relationship. And after creating a relationship between the tables, we won't actually be calling it tables again, but we'll actually be calling it a data model. So let's now create a data model. So get yourself into the power pivot tab there. Come to this point here for the data model group. Hit on manage. Then you'll actually come to this point here. Then you have to get yourself into from other sources, that is get external data from other sources. I'll click on it like that. Scroll down there because I'm actually picking from Excel file. I'll click on Excel file like that. Then I hit on next. Then on this point, it will actually tell me browse. So you select the file. So I'll hit on browse like that. Then I'll actually come to this point here. So from this point, we can click the first one, which is actually patients clean, which is actually our first file. Then I hit on open. Then you have to use the first row as column headers. Yes, we are actually using the first row as column headers. That's it. And I would actually want to explain this. Allow me to explain that. So if you come to this point here for the file, so let me actually select the patients file so that I can explain to you what we mean by that. So what we actually mean by selecting the first row as the column headers, you can actually check that in this point we have row 1, and row 1 actually has the column headers. It has the patient ID, the age, the gender, ethnicity, first admission date, age group. So this row 1 actually has the column headers. So I have to tick so that this row 1 will actually be used as the column headers. That's where you must actually check on that. So allow me to close this. So let's actually go back again. And that's all. So it's actually the reason why you must actually use the first row as column headers. So hit on next. Then that's it. Then go to finish. Now you will actually be seeing that file down here, which is actually the patient's file. So hit on close. Now that's it. So this is actually for the patients. You can actually check it up there. This is actually for the patients. So I can just double click on this sheet 1 and have it as patients, just like that. It's actually enough, patients. So this is actually the file for the patients, and you have actually imported it. Now, I would also want us to import the different one or the second file in our list. So still into get external data, we have what you call from other sources. You click on from other sources, scroll down there to where we have Excel file. You click on the Excel file, then you have to tick on next. Then on this part, you have to browse again. So we browse, that is, we go to the second file, importing the second file. After the patient's file, we have what you call the treatments file. So you click on it like that, then you hit on open. After hitting on open, make sure you actually tick this box here. That is, use first row as column headers. Then hit on next. Then hit on finish. So that's all. Now it will actually take some seconds. Before it's actually somewhere here, just adjacent to the patient's sheet. So that's it. And now we can actually call this the treatments file, or we can just rename that sheet to be treatments. So that's all. Rename this to be treatments. Then click outside, and that's it. Now I would also want us to import our file number 3. So what you have to do is to get into get external data, that is inside the home tab. Then from other sources, then I scroll down here to where I have the Excel file. I click on the Excel file there, then I go to next. Then on this point, I have to browse. So I'm actually going for file number 3. So browse, then I actually pick for lab results. So for lab results, I'll hit on open. Then I tick on use first row as column headers. We have actually seen what that means. So go to next again, then hit on finish. Then after hitting on finish, it will actually import and tell you close. So in this point here, you will actually have the lab results. So it will actually close on this part when importation is actually done. Then we can now edit the name of the sheet or rename sheet. That is from sheet 1 to lab results. So double click there and have lab underscore results. Just like that. Then you just click outside. Then now I want us to import our last file. So our last file is basically for the admissions. So we still have the admissions file. Remember, they were actually 4. Don't forget that. So inside the home tab, get external data from other sources. I'll click on it like that. Scroll down here. My file is actually an Excel file. And down there, I hit on next. Then I go to browse. So we are actually going to pick the admissions file. So browse, then I pick on the admissions file. Then I hit on open. Then on this part, we have use first row as column headers. We have seen what that means. So in this part, I'll hit on next, then I'll hit on finish. So the importation is actually in progress, and you'll actually see it here. That is the admissions table. So I'll hit on close there, and the file will actually be imported, and you will actually see it here. That is sheet 1. So we have to double click so that we can rename. So this one will actually disappear on its own. So let's actually wait. When this one disappears, we'll have to double click so that we can rename. So let's actually wait for the dialog box there to disappear. It has actually disappeared. So double click on this part there and have admissions. So this is basically the admissions table. So we have 4 tables here. So we have the patients table, we have the treatments table, we have the lab results table, and we also have the admissions table. All these tables are actually in different sheets. So this one was actually sheet 1, this one is sheet 2, sheet number 3, and sheet number 4. So this is basically what you call the data view. Data view because you can actually shift from one table to another. This is basically the patients table. You can go to the treatments table. You can also get yourself to the lab results table, and you can also get yourself to the admissions table. So this is basically what you call the data view. That is why inside the home tab, we have what you call view group. You can actually check that data view has been activated. But if you would actually want to go into creating a model, you can actually check that this is a model. So to get yourself into creating a model, you have to click on diagram view. You have to activate it. So activate the diagram view and you will actually get something like this. Yes, now you can actually check that data view has been deactivated and diagram view that is inside the view group has been activated. So you can actually check that we have the scroll bars here. We also have the scroll bar here, the scroll bar, and also the scroll bar on the other case. So we can actually avoid using the scroll bar there. So we have to enlarge it like that so that everything will be visible so that we do not have to use the scroll bars. So just enlarge everything like that so that we do not have to use the scroll bars. We have to get everything to be very visible because this is one of the most crucial stages, that is data modeling. So that's all. Now you should be happy up to this point. So in this part, I want us to identify the primary keys because it will actually help us when it comes to data modeling. So a primary key is a unique key. So like in this point here, we actually know that we have the admissions ID in this point here for the admissions table. And we also have the admissions ID when it comes to the treatment. You can actually check that for the patients table, we have the patient ID being common here. And in this point here, we also do have the patient ID. And we also do have the patient ID when it comes to the admissions table. So we have the patient ID when it comes to the patients table. We have the patient ID when it comes to the lab results, and we also have the patient ID when it comes to the admissions table. Yes. So on this part too, you can actually check that for the admission ID, we have the admission ID when it comes to the treatments table. And we also do have the admission ID when it comes to the admission table. Now, I would actually want us to link basing on the patient ID and the admission ID because those ones are actually the common columns here. So in data modeling, we actually link the common columns. Like in this point here, we have the patient ID and the patient ID. So we can actually link this table here and this table here basing on the patient ID. That's just an example. Now let's actually go into the real data modeling. So in this part here, we have to identify the primary key. The primary key in this point, this is actually for the patient's table. And for the patient's table, the patient ID will actually be the primary key. Yes. So remember this patient ID, when it comes to the patient table, will be the primary key. This is what the patient will actually be using when he goes for lab results and when he also goes for the admissions. So this one here is the primary key and should not be duplicated. So this one here is the primary key. A primary key is an item that is actually used to identify something. You know, like the patients cannot actually share the same ID. So if one of the patients is actually carrying A001000, that becomes a primary key. They cannot actually share that key. So this is basically the primary key. And on this part here, we have the admission ID here, and we also have the admission ID there. So this is basically the admissions table. Yes, this is where we have all the details. This is basically the admission table. And when it comes to the admission table, we will have the admission ID being the primary key. So let's now see how we can connect all these four tables, given that we already have the primary keys. When it comes to the relationships in data modeling, we are always connecting from many to one. That is, we actually go pointing the primary key. So we point the primary key. Like in this point here, we have the admission ID here, and we also have the admission ID there. And this admission ID inside the admissions table is actually the primary ID. So what you have is to drag the admission ID inside the treatments table into the admission ID inside the admissions table. So we go pointing the primary key. So we drag from the treatments table all the way to the admissions table, just like that. So from many to one. So from many to one. So this one is actually one. Yes, because it's actually a primary key. So you can actually check that the relationship here is actually many, which is actually the use of a star, many, and this point here is actually 1. So we have actually dragged from admission ID inside the treatments table to the admissions ID inside the admissions table. So basically that's how you actually create a link, and this one is what we will actually call a one-to-many relationship. So do not actually confuse this. So we are actually dragging from many to one, but the relationship is actually here. You can actually check that it is 1 2. You can actually check that it's actually pointing this side here, that is to many. So it is actually one to many relationship. So do not actually confuse that. So we are dragging from a point of many and dropping it to primary key. Yes, but the relationship itself will be one to many relationship. So let's also come to this point here. So in this case, you can also check that we have the patient ID. And for the patient ID here, you can actually realize that this patient ID inside the patient's table is actually the primary key. Yes, this one is actually the primary key. So what you have to do is to drag this one here inside the lab results table and drop it inside the primary key there. That is the patient ID inside the patient's table. So drop it there just like that, and a relationship will be created. So you have to drop it to where we have the primary key. So this is basically the primary key. So you come to this point here and drop it there to where we have the primary key. So this is basically a one to many relationship. You can actually check that this arrow is actually pointing the other side. So it's actually a one to many. Just like that, and you'll realize that we have actually linked this table here, which is actually the patient's table and the lab results table. In this case too, we also linked the treatments table and the admissions table. So you can actually check that these are two models. Yes, so this is one model. We have actually two relationships, this one here and this one here. So we have not actually linked this. You can actually check that this one here is actually pending. So we have to link this one here to either this or this, or this one here or this one here to either this or this. Yes, they are actually pending. So if so what you have to do is to identify the common factor. Now you can actually check that we have now you can actually identify that in this point we have the patient ID here, and we also have the patient ID there. So this patient ID here is actually the primary key. So we actually drag towards the primary key. Remember that. So we drag towards the primary key. So this is basically the primary key. That is the patient ID inside the patient's table. You drop it there, and that's all. Now all these have actually been linked. Now you can actually check that this one here, yes, is actually linked to this. So this one is actually linked to this, which is actually okay. This one too is actually linked to this one here, and this one here is also linked to this. So the four tables have actually been linked together. That is it. So when the four tables have actually been linked together, now we can actually proceed and go into the pivot tables so that we can actually analyze or come up with the deep insights about these tables. So remember, we are actually dragging towards the primary key. So drag towards the primary key. Do not make a mistake. So you can't actually come from the primary key and drop it here to many. No. So you come from a point of many towards one. So point of many towards one. Point of many towards one. Just like that, and it will be very simple for you. So you have to identify the primary keys, and after identifying the primary keys, everything will actually be very simple. So in the next video, I'll also show you how we can deal with the pivot tables and come up with the different reports, and also come up with deep insights. To actually get into the pivot table, you can actually check that inside the home tab, we have this pivot table here. So you click inside the pivot table there, and after clicking inside the pivot table, it will actually ask you, are you creating a pivot table in a new worksheet or in an existing worksheet? In my case, I would actually want to have it in an existing worksheet. I'll actually clear that, and just select a point here. Let's say I select A2. So a pivot table will actually be created there on A2. So hit OK. Now you can actually check that on A2, a pivot table has actually been inserted. So these basically are the tables that we actually had. Remember, we had the admissions table, and inside the admissions table, click on that right arrow. We add all these kinds of columns. So click on it again to collapse. And when it came to the lab results, click on the right arrow. We add all these kinds of columns. Click on it again. And when it comes to the patients table, we actually have these kinds of columns. And finally, when it comes to the treatments table, we can actually expand to check on the columns. These ones are actually the columns. Click on it again to collapse, and that's all. Now I would actually want us to start doing the analysis. So I want us to start with the patient demographics and profiles. So when it comes to the patient demographics and profiles, I would actually want us to check the age groups and the genders which actually dominate the hospital. So we can actually start with the age groups. So which age groups actually dominate the hospital? So remember that you can always expand so that you can actually check. So expand so that you can actually look for the age groups, and you will actually realize that the age groups is actually inside the patients table. So we have to drag the age group into the rows. So which age group actually dominate the hospital? So we have the age groups here. We have the adults, we have the child, we have the senior and the young adult. So those ones are actually the age group. But how do we actually identify the ones which are actually dominating the hospital? We have to count the patient IDs. So in counting the patient ID, it will actually be counting for the adults only and get us the results there. It will also count for the children alone, for the seniors alone, and for the young adults alone. And we will now identify the age group which actually dominates the hospital. So we'll actually go into the count of patient IDs. So we'll actually drag the patient IDs into the values, just like that. After dragging the patient ID into the values, it will actually get you count automatically. Remember, when it comes to the values, if you drag something that is not actually numerical, then it will actually get you count. But if you drag something which is actually numerical, then it will actually get you the sum. That is, if you drag something like cost, because cost is actually numerical, if you drag something like cost into the values, then it will actually get you the sum. You can actually check that we have the sum of cost. But if you drag something which is not actually numerical, yes, then it will actually get you the count. Now we have the count of patient IDs. Now you can actually check that for the adults, we add 370 adults. For the children, we add 75 children. For the seniors, we add 156 seniors. And for the young adults, we actually had 199. Now you can actually rank this, or you can actually sort from the largest to the smallest, or from the smallest to the largest. So click on one of the values there, then you actually right click. I have actually clicked on 370 and right clicked. Then after right clicking, we have sort. I will say sort from the largest to the smallest. So this is it. So you can actually give a report that adults actually dominate the hospital because we have a count of 370 adults, followed by the young adults, which actually have a count of 199, followed by the seniors, who are actually 156, and finally we have the least number of children in the hospital, or we have the least number of children reporting to the hospital for treatment, and the number actually stands at 75. So the highest number of people reporting to the hospital for treatment is adults at 370, and the least age group reporting to the hospital is actually children, with their count standing at 75. I would actually want us to give a visual representation of this. So clearly, you can actually check that the items are 4. So we can actually use the pivot chart. So to insert the pivot chart, you have to get yourself into the pivot table analyze tab there. Inside the pivot table analyze tab, we have the tools group. Then we have the pivot chart. Then we have what you call a pie chart. Just like that. And you can always hover your mouse there so that you can actually get a preview of the data. So this is basically how my data will actually be looking like. So I'll hit on OK there, and this is it. So this is basically the analysis, and that's all. So I would also want us to check on the gender which actually dominates the hospital. Yes. So for the gender which actually dominates the hospital, we have to do away with this one first and do away with that one again. So we will actually drag the gender into the rows, just like that. Now you can actually check that I have the females and I also have the males. And we will actually drag the count of patient IDs into the values. That is the patient ID into the values, so that it will actually obtain us the count. When the items are actually 2, it's not always advisable to use a pie chart. So in this case, I'll actually delete this. I'll hit delete on the keyboard after selecting it like that. Then I'll actually click inside the report. This is basically the report. So I'll actually click inside the report, get myself into the pivot table analyze tab, tools group, pivot chart. Then after hitting on the pivot chart, it is always advisable to use this one when the items are actually 2. So I'll click on the column chart like that. Then hit on OK. And this is it. Now you can actually check that we have the females and we have the males. So clearly you can check that the female patients are actually dominating the hospital, with the count actually standing at 426 patients. And on this point here, you can actually check that you can actually check that the male patients are actually the least, with their count actually standing at 374. And this is actually the visual representation of that. So we have already seen the age group which actually dominates the hospital, and we actually identified that it was the adults. And we have also seen the gender which actually dominates the hospital. Now, I will also want to show you how we can have both the gender and the age group inside one report. You actually realize that we had to do away with the first report so that we can actually create this second report. So I want us now to have the gender and the age group inside one report. It's actually very possible. So what you have to do in this point, allow me to actually, you can actually click on it. So I'll actually take it like that. Now in this point here, I want us to check on the age group which actually dominates the hospital. So for the age group, we'll actually drag it into the rows like that. Then into the values, you'll actually drag the patient ID so that it can actually count the number of patients. So allow me to delete this one first. I'll click on it like that and hit delete. So we have the age group, which is actually adult, child, senior, young adult. And on this part too, for the values, we have the count of patient IDs. So in a layman's language, a patient ID is actually a patient. I would also want us to have the gender inside this report. Now let me actually explain to you the structure of this report. You can actually check that in the rows, we have the age group. So these ones are actually the rows. Yes. So we have the age group, that is the adult, the child, the senior, the young adult. When it comes to the columns are actually B, C, D, E, F. That's basically the columns. If we had actually dragged the age group into the columns, then we could have actually been having the adult standing on its own column, the child on its own column, the senior on its own column, and finally the young adult on their own column. We can actually check on that. So I'll actually drag that age group into the columns, and now you can actually check that adult, child, senior, young adult, they are all having their own columns. But that's not actually what I wanted. I wanted to have them inside the rows so that it can actually be neat. So if we actually drag the gender into the columns, then we will actually be having females and males in B and C. Allow me to actually do it so that you can actually check. Now you can actually check that we have on B and C, we have females and males. So this 370 has actually been broken down further, so that when it comes to the adults, now we can actually check that we have 191 adults who are actually females and 179 adults who are actually males. That comes to a total of 370. When it comes to the children, we can actually say that out of these 75 children, 44 children who actually came to the hospital are actually females, and that one of them are actually males. On this part, we can actually say that out of the 156 seniors who actually came to the hospital, 84 of them were actually females and 72 of them were actually the males. On this part 2, we can actually say that out of the 199 young adults who actually came to the hospital, 107 of them were actually the females and 92 of them were actually the males. That's it. So when it comes to checking on the gender which actually dominates the hospital, you can check that for the females, I have a total sum of 426. And for the males, I have a total sum of 374. So clearly you can check that the females dominate because they have the highest number of 426. And the total patients in this case is actually equivalent to 800. Now, when it comes to analyzing the age group that actually dominates the hospital, these ones are actually the age group, because in the age group, we are not actually considering the females and the males, but we are just considering the number. 191 plus 179, 370. 44 plus that one, 75. 84 plus 72, 156. 107 plus 92, 199. So I would also want us to check on the health disparities across the ethnic groups in this top care hospital. So health disparities across the ethnic groups. So we have ethnicity, and so for us to actually remove this report there, we have to, that is, we have to deselect the patient ID there, deselect the gender, and for the age group, you can just drag it out just like that. It's always very simple. So when it comes to health disparities across the ethnic groups, that actually means that we will be dragging the ethnicity into the rows. Now we would actually be wanting to check the number of Kalenjins that we actually do have in the hospital, the number of Kampas, the number of Kikuyus, the number of Luyas, the number of Luos, and others. So it's actually very possible for us to actually come up with their number. So what we actually do is to obtain the count of patient IDs, because I actually told you that in a layman's language, a patient ID is actually representing a patient. So we have to drag the count of patient ID into the values, just like that. And now you can actually check that we have Kalenjins standing at 149, Kampas standing at 129, Kikuyus actually standing at 136, Luyas actually stand at 115, Luos actually stand at 130, others actually stand at 141. And for you to actually obtain this one in an ascending or a descending format, what you have to do is to click on one of the values there, then you actually right click, then you actually sort. So you can actually sort from the smallest to the largest. That is the least ethnic group appearing at the hospital. It's actually the Luyas. It's actually standing at 150. And you can also right click so that you can actually sort from the highest, that is from the largest to the smallest, and you can actually check that the ethnicity with the highest attendance in the hospital or the highest appearance in the hospital is actually Kalenjins with 149. So basically that's all about health disparities when it comes to the ethnic groups. Now you can also break down this 149, 141 into females and males. You can always break down these numbers so that you can identify out of this 149 which ones are actually the males and which one are actually the females. We can be having 79 to be the females and also have 70 to be the males. I want us to break down the count of patient IDs so that we can identify the females and also the males. So what you have to do is to drag the gender into the columns so that we'll now be having the females on this part here and males. So that instead of us having 149, we can have the females at 79 and the males maybe at 70, then the total now at 149. Let's actually see that. So drag the gender into the columns there. Now you can actually check that for the ethnicity Kalenjins, the females is actually 77, and for the ethnicity Kalenjins still, the males actually stand at 72 and the total is actually 149. So that's all. We can actually say that Kikuyus have the highest number of female patients appearing at the hospital, and the number is actually equivalent to 81. Yes. So Kikuyus, which is actually the ethnicity, have the highest number of female patients appearing at the hospital, and the number is actually equivalent to 81. We can also say that Kampas, which is actually the ethnicity, have the least number of female patients appearing at the hospital, and that number is actually equivalent to 56, just like that. Now when it comes to the males, these ones are actually their records. Now you can actually check that the highest number here in Top Care Hospital is actually 73, and it actually belongs to the campus. So we can actually make a conclusion that Kamba males have the highest appearance at the hospital, and the number stands at 73. And Luyas, that is the Luya males, have the least number of patients appearing at the hospital, and the number actually stands at 52. So that's all when it comes to analyzing the ethnicity and the gender. We'll be checking on the admission trends and the volume analysis. So I would actually want us to check on the busiest departments. So I want us to identify the busiest department. So to identify the busiest department, remember the department column was actually inside the admissions table. This is it, and it's actually inside the admissions table. So we will actually be dragging the department into the rows. Now we have the departments there from cardiology all the way to surgery, but we do not actually know the number of times these departments were actually visited by the patients. So to know the number of times these departments were actually visited by the patients, you have to obtain the count of the departments. That is, how many times does cardiology actually appear? How many times does emergency actually appear? The count of those departments. So to obtain the count of the departments, we have to drag the department into the values. So that's it. So this is now the count of the departments. So cardiology actually appears 178 times. That actually means that this 178 represents the number of patients who are actually treated in the cardiology department. This one here, which is actually 185, actually represents the number of patients who are actually treated in the emergency department. So I would actually want us to have this in an ascending order, or I would actually want us to have this in a descending order. That's from the largest to the smallest. So you can actually check that the department which had the highest number of patients is emergency, because the number of patients there is actually 185, and obstetrics department actually is the least busy department. So that's it. We have our departments here, and we have the counts of the departments. If you do not actually want to use the count of the departments, you can also use the admission IDs. So you can drag the admission IDs into the values. Just like that, you will actually obtain the same thing. If I actually rank this, we will actually have 185 to be on top. So you click on one of the values there, right click, then sort from the largest to the smallest. So this is it. Now this is the logic behind that, because in this point here, when the patients are actually admitted, they are actually given a certain department depending on their treatment. Yes. So a patient who actually goes into emergency department actually has an admission ID. Yes. And the patient who also goes to the orthopedics department also has an admission ID. So basically, we are obtaining the count of all the admission IDs of the patients who actually went to the emergency department. In this point too, we are obtaining the count of all the admission IDs of the patients who actually went to orthopedics department. The same applies to this point here. We are obtaining the count of all the admission IDs of the patients who actually went to the cardiology department. This is 172. This one represents the total number of patients who actually went to the pediatrics department. This is 164, and it actually represents the total number of patients who actually went to the surgery department. 163 is actually the total number of patients who went to the general medicine department. And finally, 158, which is actually the list here, is the total number of patients who actually went to the obstetrics department. So basically that's it. So that's how you can actually identify the busiest department and the least busy department, which is actually obstetrics in our case. So remember, you can also have this one here represented in a pie chart. So just inside the pivot table analyst tab there, we have tools group. Click on the pivot chart there. Then on this point, we can just click on the first one there. That's this is basically what you call the column chart. You can actually check that we have used the columns just like that, and you can actually check that this is a simple column chart. So in the column chart, the advantages of actually using the visualizations is that you will make the conclusions very quickly without actually having to get yourself into the data. Basically, you can check that emergency as the highest column, so it's actually the most busy, and you can actually check that obstetrics is actually having the smallest column, meaning that it is the least busy. So that's all when it comes to checking the busiest departments. And I also want us to check on the most common diseases in the hospital. So for us to actually check on the most common diseases in the hospital, first of all, allow me to actually remove that report there. So in obtaining the most common diseases in the hospital, remember that the column for diseases is actually inside the diagnosis, just like that. So these are basically the diseases. That is anemia, appendicitis, arthritis, COVID-19, diabetes mellitus, fracture, gastritis, heart failure, hypertension, malaria, pneumonia, UTI. So we would actually want to see the count of these diseases. How many times does anemia actually appear? How many times does COVID-19 appear? How many times does malaria actually appear? So it's actually very simple for us to obtain the count of the diseases. So to obtain the count for the diseases, we can still drag the same diagnosis into the values so that you can obtain the count of the diseases, which is actually the count of diagnosis. Drag diagnosis into the values and you will obtain the count of diagnosis, which is basically the count of the diseases. So allow me to actually click inside the count of diseases like that, or the count of diagnosis. Right click there, then sort. Then we'll actually be sorting from the largest to the smallest. So you can clearly check that the most common disease is actually appendicitis and anemia, because we have 113 to be the number of patients treated in that hospital, which is top care hospital. After appendicitis and anemia, the disease number 3 is actually arthritis, which actually appears 108 times. That actually means we have 108 patients who have actually come to the hospital, to top care hospital, for arthritis treatment. In this point here, you can actually check that we have 105 patients who have actually come to top care hospital for diabetes mellitus treatment. On this point, we have 104 patients who have actually come to top care hospital for COVID-19 treatment. In this case here, we have 84 patients who have actually come to top care hospital for gastritis treatment. And finally here, you can actually check that for malaria, we have 80 patients who have come to the hospital for the treatment. So clearly you can check that the most common diseases are appendicitis and anemia. In this point here, we can just say we would like to filter the top 3. So for us to actually obtain the top 3 only, because we might not actually be interested with all this. So to obtain the top 3, what you have to do is to click on this column here, because that's where we actually do have the filter. We do not have the filter here. We have the filter there inside the row labels. That's for the diagnosis or for the diseases. Then we actually right click, and after right clicking, we have what you call filter. So click on top 10. In this point here, we will actually select on this down arrow, we'll select top 10. So in this point here, we'll actually hit on this down arrow so that we can pick top 3. So top 3 items by count of diagnosis. Yes, we are basing the top 3 values using this count of diagnosis. That is 113, 113, and 108. Those are our top 3. Just like that, and we hit OK. And now you can actually check that we have top 3 diseases being treated in the hospital, because most of the patients actually come for this treatment here. That's anemia treatment, appendicitis treatment, and arthritis treatment. So that's it. So allow me to actually clear this filtering here. So I'll actually come to that point and hit clear filter from diagnosis. Click on it like that, and that's all. Now in this point, let me also show you how we can obtain this count of diagnosis. So I won't actually remove this. So in this point here, remember that every patient who actually comes for treatment will actually be having the admission ID. So what you have to do is to drag the admission ID into the values so that you can obtain the count of the admission IDs, because every patient who comes to the hospital or who is actually treated in the hospital has the admission ID. That's it. So if a patient has been treated of anemia, then it actually means that the patient had the ID. So we just have to count the admission IDs which actually link to the disease anemia, which is actually equivalent to 113. The admission IDs which actually link to the disease fracture is actually equivalent to 82. The admission IDs which actually link to the disease UTI is actually equivalent to 102. So that's it. So you can actually check that it's the same thing. So you can actually use the count of diagnosis or the count of admission IDs. Now, in this point, I would also want us to check on the diseases which actually have high readmission risk. So after a patient has actually been treated in top care hospital, they are actually discharged, just like in any other hospital. So when they are discharged, we would actually want to identify the kinds of diseases which actually have high readmission risk. Because in this point here, we actually have the readmission within 30 days recorded in our data. Remember that. So we actually had in this point here, readmission within 30 days. You can check that, readmission within 30 days. So when the patient has actually been discharged and within 30 days, they actually come back. That's what we call readmission. So of all these diseases, which one actually leads when it comes to readmission? So to identify the readmission risk, we have to get ourselves all the diseases, then we get the summation for the readmission. So allow me to actually clear that report there. So we will have to drag the diagnosis into the rows like that. Then after dragging the diagnosis into the rows, we will drag it into the values, just like that. So we have the summation within 30 days. So we have the summation of readmission within 30 days. For anemia, we have the total number to be equivalent to 16, appendicitis 12, arthritis 12, COVID-19 9, diabetes mellitus 20, just like that, up to the last item there where we have UTI to be equivalent to 6. So the number of patients, allow me to actually interpret all this for you. So in this point here, we add the patients treated of anemia. And when the patients were actually discharged, some of the patients came back for readmission. So you can actually check that when it comes to anemia, the total number of patients who were actually readmitted within the 30 days is actually equivalent to 16. When it comes to arthritis, the total number of patients who were readmitted within the 30 days is equivalent to 12. So allow me to actually sort this in a descending order. So right click there, sort descending order. That's from the largest to the smallest. So we have diabetes mellitus to be 20. We have anemia to be 16, hypertension 15. So clearly you can check that in this point here, diabetes mellitus patients actually lead when it comes to readmission. We have 20 patients readmitted within 30 days. That actually tells you this one is actually of high risk, followed by anemia where we have 16 patients readmitted within 30 days. The disease with the least readmission risk is actually UTI, because the total number of patients who have actually been readmitted within the 30 days is actually equivalent to 6. So clearly we can actually say that diabetes mellitus is the disease with the highest readmission risk in this hospital. We can also identify the department with the highest readmission risk. So what we'll actually do is to drag out the diagnosis there and drag in the department into the rows. So clearly you can check that we have cardiology department having 24 patients who have actually been readmitted within 30 days. We have the emergency department having the total number of patients readmitted within the 30 days to be 13. We have general medicine having the total number of patients readmitted within the 30 days to be 18. Obstetrics has the total number of patients readmitted within the 30 days to be equivalent to 29. Orthopedics has the total number of patients readmitted within 30 days to be 17. Pediatrics is the department with 16 patients readmitted within 30 days. Surgery is actually the department with 26 readmitted patients. Right click there so that we can obtain in descending order. So clearly we can actually say that obstetrics, because it has the highest sum of readmission, obstetrics is actually the department with the highest readmission risk. Why? Because it has the highest number of patients readmitted after 30 days. And what is the number? The number is actually 29. And emergency is actually the least. Emergency is actually the department with the least risk when it comes to readmission, because the total number of readmitted patients within the 30 days is actually equivalent to 13. So that's all about the department. So we can also analyze the readmission based on the age groups. So the age group with the highest readmission risk. So the age group with the highest readmission risk, what you have to do is to actually drag out department and go down there to where we actually have age group. Age group is actually inside the patient's table, and then we actually have to drag the age group into the rows, just like that. So clearly you can check that adults is actually the leading age group when it comes to the number of patients who have been readmitted, because the total number of patients who have actually been readmitted is actually equivalent to 71. So allow me first to sort this in a descending order, just like that. So 71 is actually the total number of patients who have actually been readmitted within the 30 days, and these patients actually belong to the adult age group. So clearly we can say that the age group with the highest readmission risk is actually the adults, because the total number of patients who have been readmitted within the 30 days is actually 71. And the age group with the least readmission risk is actually the children, because the total number of children who have actually been readmitted within the 30 days is actually equivalent to 9. So that's it. So I can come to this point here and show you how that can actually be analyzed quickly by using the pie chart. So hit on OK here. So clearly you can check that the largest piece here is actually this blue one, which is actually belongs to the adults. So that's it. Given that this is actually a private hospital, so the key thing is actually business, apart from actually the health matters. So the key thing is actually money. So I want us to actually try and do the analysis for the cost and finance, so that you can actually see the department which actually generate a lot of money. The diseases which are actually very complicated to treat or very expensive to treat, and the distribution of money by NHIF, the private, and by cash, the total amount of money received through NHIF, the total amount of money they received through private insurance, the total amount of money received through cash. So we can actually have all that kind of cost and financial analysis in this part here. So first of all, I want us to obtain the top 3 departments which actually generate the most revenue. So top 3 departments which generate the most revenue. That actually means that we'll be dragging the departments into the rows, then into the values we'll actually be dragging the cost, so that we can actually obtain the total cost of treatment in every department. So the total cost of treatment in every department is actually the total revenue obtained in every department. That is, if we have actually treated anemia, and we have actually said that the cost for treating anemia is actually equivalent to $1,000, then it actually means that $1,000 is actually the revenue that you have actually generated from treating what? Anemia. So we'll have to sum all the cost for all the departments, so that you can actually identify the departments which actually generate the highest revenue. So what you have to do in this point is to drag the department into the rows. So drag the department into the rows like that. Then we also have to drag the cost into the values. Very simple. So we have our departments here, yes, and we also have the sum of cost or their cost here. So you can actually check that cardiology, this is actually a department, and it was actually able to generate 7998381. So what we can actually do in this point is to introduce a comma. So select all of them like that, then come to this point here, that is inside the home tab, number group, hit on this comma here. Then you can actually check that we have up to 2 decimal places, then it's actually a comma. So remember, all these revenue is actually in Kenya shillings, not US dollars. So from the cardiology department, we were actually able to collect 7,998,381 Kenya shillings. For the emergency department, we were able to collect 8,024,154 Kenya shillings. For the general medicine department, we were actually able to collect 6,901,701. All the way up to the last one, which is actually surgery department, we were actually able to collect 7,551,011 Kenya shillings. So I would actually want us to have the top 3 departments. That is when it actually comes to the revenue. So what you have to do in this point is you click on one of the items inside the row labels there, because that's basically where we have the filters. Then right click. After right clicking, we have what you call the filter item there. Then top 10. Then in this point here, we want top 3. So reduce, so that we can actually have 3 items by sum of cost. Yes, our top 3 items will actually be based on the revenue, and revenue in our case is actually the sum of cost. So hit OK there, and now we can actually say that when it comes to generating the highest revenue in our hospital, we actually have these 3 top departments. The first department which actually generates the highest revenue is the orthopedics department, which actually generated 8,380,910 Kenya shillings. In this point here, we have the second department, which is actually the emergency department, which actually generated 8,024,154 Kenya shillings. And finally, that is our last one when it comes to top 3. We have the cardiology department generating 7,998,381 Kenya shillings. So these ones are actually the top 3 departments when it comes to revenue. I would also want us to check on the most expensive diseases to treat. So when it comes to the most expensive diseases to treat, remember the diseases are actually inside the diagnosis column. So I can actually deselect this and deselect this. So I can actually drag the diagnosis into the rows. That's it. So we have the diseases there. So the diseases are actually there, and we would actually want to identify the most expensive diseases to actually treat. So for the most expensive disease, it should actually, so the most expensive disease is actually the one which is actually having the highest cost. So the one which is having the highest cost is actually the most expensive disease to treat. So basically we have to drag the cost into the values, but that's not actually enough, because in this point here, we are actually getting anemia, and this is actually the total cost of treating all the patients who actually had anemia. This one here is actually the total cost of treating all the patients who actually had appendicitis. This one here is actually the total cost of treating all the patients who actually had arthritis. Up to the last one here, which is actually 480,9401, and this is actually the total cost of treating all the patients who actually had a UTI. So what we can actually do in this point is to obtain the average of the cost. So to obtain the average of the cost, so that you can actually see the cost per patient when it comes to anemia, the cost per patient when it comes to appendicitis, that one will be the average cost, and it will be so quick or so easy to actually understand it by using the average instead of sum. The reason why we do not actually want to use sum and use average is that there are some diseases here which have actually appeared more than others. It's not that they are expensive, they have appeared severally. Some diseases here have not actually appeared too much, but they actually have a high sum of cost. Actually meaning, if we are going to run the average, then it will actually get us the true picture when it comes to the average cost of treating a disease. So we would actually want to obtain the average cost of treating a disease and not the sum of cost, because we do not have an equal number of the diseases in our data. No. So we have to click on this down arrow here, then value field settings, then we actually go to average, and you'll actually realize that we'll actually obtain a bit different things. Clearly this is what we have. I'll actually select it like that, then I reduce the decimal places to 2 like that, then I also add a comma there, and that's all. So I can actually click on the data again there, then I right click so that I can sort from the largest to the smallest. So clearly you can check that the average cost of treating fracture is actually 51,134.43 Kenya shillings. So this one actually gives a true picture when it comes to treating a disease. So for malaria, you can actually check that it's 480.42.64, that's Kenya shillings. The disease which is actually the cheapest to treat is actually anemia, and the cost is actually 39,792.71 Kenya shillings. So anemia is actually cheapest to treat, and fracture is actually the most expensive to treat. So fracture 51,134.43 expensive to treat, anemia 39,792.71 the least expensive or the cheapest disease to treat. In this case, I would also want us to check on the revenue distribution. So remember, we actually add the NHIF, we also add the cash, we add the private insurance. So I would also want us to check on the distribution of this revenue. What amount was actually received through NHIF? What amount was actually received through cash? something like that. So we would like to check on the revenue distribution. So we have to get ourselves into the insurance type. So I'll actually deselect that, deselect this again, and drag the insurance type into the rows. Then I actually drag the cost into the values. That's the sum of cost. Very simple. So clearly you can actually check that we have cash, we have NHIF, we have others, and we have the private insurance. So I will select all this like that. Then I hit on this comma here, which is actually 1,000 separator. Then for the 2 decimal places, it's actually okay. And this one's actually in Kenya shillings. Allow me to explain this. When it comes to cash, so for all the patients who actually paid through cash, the total amount collected was actually equivalent to 10,347,342 Kenya shillings. For those patients who actually paid through the NHIF, NHIF actually is an insurance which is actually given by the government. So this one is actually the National Health Insurance Fund. So the total amount that the government actually paid through NHIF for those patients who actually had the NHIF insurance was actually equivalent to 25,342,337. Others, that is the other means of payment, it was actually equated to 4,612,632. Others can actually be payment through crypto if at all the hospital actually allows that. For the private insurance, we have different kinds of private insurance. Like for example, in Kenya, we have AON, we also have AAR. So all those are actually the private insurance. So the total amount collected through the private insurance, such as AON, AAR, was actually equated to 14,107,721 Kenya shillings. So you can always represent this. You can actually check that there are only 4 items. You can get yourself into the pivot table analyze tab quickly, pivot chart there. Then you just pick on the pie chart there. Then you hit on OK. And you can clearly check that the largest portion actually belongs to this one here, which is actually the NHIF. So NHIF actually takes the largest portion, which is actually 25,342,337. So remember, you can always format so that you can get the data labels. So we can just hit on the data labels so that you can have it in this part here. So for the NHIF, you can actually check that this is actually the key, 25,342,337. On this part here for the cash, 10,347,342. On this part here for private insurance, 14,107,721. And on this part here for the gray color, it actually represents other payments. And this is 4,612,632. So basically, this is the distribution of revenue by insurance types, and this is actually the simple visualization. So I would also want us to check on which patients are actually the most expensive to treat in terms of age group and gender. So in terms of age group and gender, what you have to do, first of all, you have to deselect all this so that that report can actually disappear. So the most expensive patients to treat in terms of age group and gender. So first of all, you have to drag the age group into the rows. Yes. Then after dragging the age group into the rows, remember we have the adult, the child, the senior, the young adult. So these ones will actually be broken down because you would like to see the cost by age group and gender, not just age group. That actually means we should also be having the gender on this part here, which is female and male on this part here. So we have to drag that gender into the columns because this one here is actually going into the rows. You can actually check that for the age group, we are actually arranged row wise. So for the column wise arrangement, we have to take gender into the column, just like that. And now you can actually check that I have females and males. So allow me to also increase the space here, just like that. And I want them to be almost of the same size. That's cool. Now in this part, we have to drag the cost into the values. So drag the cost into the values, just like that. Now select all this like that, then hit on 3 comma separator. So this 3 comma separator will actually, so this 3 comma separator is what we always call a thousands separator. Click on it like that, and it will automatically get to 2 decimal places. So this is actually the data. And I would actually want us, you can actually check that for the adults, this is actually the total amount for the females. So it will be very good if we actually obtain the average of cost so that we can actually check on the cost of treating a male, a female, like that. So average will actually be a very key indicator. That's it. Very simple. So in this part here, you can actually check that for the adults, the average cost of treating a female is equivalent to 44,038 Kenya shillings. For the adults, the average cost of treating a male is equivalent to 46,039.73 Kenya shillings. So the average cost of treating an adult in top care hospital is actually this one plus this one divided by 2, which will actually get us 45,051.01 Kenya shillings. The average cost of treating a child, that is a female child, in top care hospital is 51,394.02 Kenya shillings. The average cost of treating a male child in a top care hospital is actually equivalent to 46,920.40 Kenya shillings. The average cost of treating a child in top care hospital is actually equivalent to this one here, which is actually 51,394.02 plus 46,920.40, yes, divided by 2, and it will actually get us the average cost of treating a child to be 49,470.36. The average cost of treating a senior female in top care hospital is 49,17.59, and the average cost of treating a senior male in top care hospital is 44,555.21 Kenya shillings. The average cost of treating a senior in top care hospital is actually this one plus this divided by 2, which will actually get us 42,799.66 Kenya shillings. The average cost of treating a young female adult is equivalent to 46,848.64 Kenya shillings. The average cost of treating a young male adult is 46,063.95 Kenya shillings. And the average cost of treating a young adult is this plus this divided by 2, which gets us 46,500.48 Kenya shillings. So clearly, we can actually say that the most expensive age group to treat, remember these ones are actually the average for the age group. So the most expensive age group to treat is actually a child, with the average cost of treatment being 49,470.36. That is the most expensive age group to treat. And the most expensive gender to treat is actually equivalent to male. You can actually check that the total for males is actually 45,807.46918, and the average cost of treating the males is actually equivalent to 45,807.47, and the average cost of treating the females is actually equivalent to 44,900.11. So 45,807.47 is actually higher than 44,900.11. So the most expensive gender to treat in top care hospital is actually the males, with an average cost of 45,807.47. And there is actually a very slight difference between the total cost of treating the males and the cost of treating the females. The other insight which we can actually come up with in this point is that there's a bigger disparity when it comes to the average cost of treating a female child and the average cost of treating a male child. Check. The average cost of treating a female child is actually 51,394.02, and the average cost of treating a male child is actually 46,920.40. You can actually check that the difference is actually something like 5,000. So it's actually big because the difference here is actually about 2,000. The difference here is actually about 4,000. The difference here is actually about it's not even 1,000. Yes, the difference here is about 800. But the difference when it comes to the treatment of a female child and the male child is actually close to 5,000. So there's a bigger disparity. I want us to check on the clinical outcomes and the quality of care. So in this point, I would actually want us to check the outcomes by departments. So we actually have different departments in our case, and we have different outcomes. So one of the outcomes is discharged. The other one is also deceased. So we would actually want to identify the different counts of outcomes by departments. So what you have to do is to drag the department into the rows, just like that. So after dragging the department into the rows, remember when it comes to the outcomes, we have the deceased, we have the discharged. So I would also want us to have those outcomes arranged column-wise, so that in this point here, we will be having deceased, we will be having discharged, we'll be having a different outcome. Then on this point here, we'll be having the total for cardiology. Then on this point, we'll be having the other total outcomes. So it's actually very simple. So what you have to do is to drag the outcomes into the columns. So drag the outcomes into the columns. Now you can actually check that for the cardiology department. Allow me to actually clear this filter here. We had actually filtered the top 3. So for the cardiology department, you can actually check that we might be having the deceased persons here. We might also be having the ones who were discharged, the ones who actually improved, the ones who were transferred to a different hospital, and so on. So I want us to actually obtain the count for all this. So to obtain the count for all these outcomes, what we have to do is to count the outcomes. That is, yes, this point here is for cardiology, and this one here is actually deceased. So I would actually want to count the deceased persons in cardiology department. That is the number of people who actually died in the cardiology department. So we still have to drag the outcome into the values, just like that, and it will be count the number of persons who actually died in cardiology department. So whenever you actually see deceased, you count it. Deceased, you count. Deceased, you count. So whenever you actually see deceased, count. Deceased, count. Deceased, count. That's why we are actually saying count of outcome. So for the cardiology department, you can actually check that the total number of deceased persons is actually equivalent to 3. Still in the cardiology department, the total number of patients who were actually discharged is 144. Still in the cardiology department, the total number of patients who actually improved is 24. Still in the cardiology department, the total number of patients who were actually transferred to a different hospital is actually equivalent to 7. And the summation for all this will actually get us 178. That's actually the total patients inclusive of the deceased who actually went through the cardiology department. And this one also, 185, is the total number of patients who actually went through the emergency department. 180 is also the total number of patients who also went through the orthopedics department. So basically, that's how you can actually do the distribution of different outcomes by the departments. And this is it. So clearly, we can come up with a conclusion in this point here that the hospital is actually trying, because we can actually check that we have 900 people who have actually been discharged. That actually means that that's a good job. We also have 207 patients who actually improved. So 900 patients discharged, 207 patients actually improved, and 68 patients were actually transferred. So we actually know that the number of persons who actually died from the cardiology department is equivalent to 3, but we do not actually know if this kind of a person is adult, senior, young adult, or a child. So I would also want us to have the distribution of the outcomes by age groups, so that you can check on the mortality rates and understand what actually happens there, so that you can also check on the number of age group which is actually discharged most, the ones which are actually transferred the most, and the ones which are actually improved the most in this hospital. So because if a certain age group actually improves the most in this hospital, then it actually means that the hospital might have actually invested in the facilities that treat majority of their ailments. So let's actually see what happens. So I'll drag this out. We will always start from 0 so that you can always understand. So we will be checking on the distribution of different outcomes by age groups. So different outcomes by age groups. So we'll be having the outcomes up there, and then we'll be having the age groups down here. So that's it. And we will actually be having the age groups. So scroll down there to where we actually do have the age groups. So you can have the age groups on the rows just like that. Then you just drag the outcomes into the columns, so that in this point here, we'll now be obtaining the values. So we will actually drag the count into the values just like that. And now you can check that the number of deceased adults is actually equivalent to 12, which is actually the highest here. And the number of deceased children is 3. The number of deceased seniors is 6. The number of deceased young adults is actually equivalent to 4. On this part, you can actually check that majority of the persons who are actually discharged are the adults, 436. Yes, 436. That's actually the highest. And the least number of persons who are always discharged here are the children, 73. Majority of the persons or age group who always show improvements in this healthcare facility are the adults, with 97 of them showing improvement in our data. That's actually very positive. And that's all. Now, in this part here, when it actually comes to the adults, we cannot actually give a very big corrective measure when it comes to the deceased, because maybe majority of their diseases are actually coming due to the old age. So that's actually what we can suspect here, that majority of their diseases are actually coming from the old age. So majority of the deceased persons in this hospital are actually the adults. If the majority of the deceased persons in the hospital were actually the children, then a very big measure had to be taken, because that can't be the old age. Something has to be done. That's all about the distribution. You can actually check that the mortality rate when it comes to the children is actually very low. Yes, it's actually a very positive sign. The mortality rate when it also comes to the energetic population is also low. It's actually 4, and that's also a very positive indication. When it comes to the seniors, it's also 6, not too bad, and it's also a very positive indication. So that's how you can actually analyze this. The mortality is actually increasing as the age increases. That actually means that the mortality rate is not too bad. And let's also check the next item. I would also want us to check on the average length of stay. That is by the disease and also by the department. So when it comes to anemia, what is the average length of stay when it comes to that disease? And when it also comes to the department, let's say cardiology, what is the average length of stay? So I would also want us to calculate that. So I'll actually click inside the report, then I just drag these out, just like that, drag them out. So in this point, because we are trying to get the average length of stay, you will actually realize that in my tables, I do not have the length of stay. Remember that. So in the admissions table, no length of stay. In the lab results table, no length of stay. In the patients table, no length of stay. In the treatments table, no length of stay. But you will actually realize one thing. When it comes to the admissions table, you will actually realize that we have the admission date, yes, and we also have the discharge date. So if you are actually admitted on 10th of May 2026 and discharged on 20th of May 2026, then it actually means that the length of stay is actually 20th of May 2026 minus 10th of May 2026, which is actually equivalent to 10 days. So we have to do the subtraction in this point, and it is not the admission date minus the discharge date. No, it's actually the discharge date minus the admission date. Now, how will we actually do all that, given that we already uploaded our data? That's where the problem comes in. Now, worry not, I got you. So in this point here, we'll actually go into the model, which is actually this part here. Then you'll actually check that we have the admissions sheet here, which is actually the admissions table. Then in the admissions table, we have a part there where we are actually told to add a column. So this will basically be our calculated column. So double click on it like that, so that you can have L or S, which is actually the length of stay. So the length of stay is basically equivalent to the discharge date minus the admission date. So click on it like that, then hit on the equivalent sign. So click on the first cell there, then hit on equivalent sign, discharge date, then minus the admission date. Discharge minus the admission date. You can actually check that the formula is actually here inside the formula bar. So admissions, that is the admissions table. Inside the admissions table, we are actually saying the discharge date column minus inside the admissions table, admission date. So discharge date minus admissions date. Don't worry about these admissions. This is basically telling you that it's actually the admissions table. So the moment I actually hit enter on the keyboard, then there will be spilling all the way up to the last item. So I'll have the results all the way, that is the length of stays, all the way up to the last item down there. So hit enter on the keyboard and you'll actually check that there will be changes all the way up to the last item. So you do not have to calculate for the first one, then you drag. No. So let's actually wait as it tries to do the calculations, and everything will actually be there in that column. Now you can actually check. We have the LOS, which is actually the length of stay. So what actually remains in our case is to come to this point here for the diagram view. Then inside the diagram view, you can actually check that it has already sensed that we have the length of stay, which is actually the LOS, or you could have just hit on the refresh button there. So you can actually hit on the refresh button and it will actually tell you that we are working on the admissions table. Then that's it, and you just have to close. So we have an added column, which is actually the LOS. This added column is actually a calculated column. So I would actually want us to check on the average length of stay by department. So the average length of stay by department. So you drag the average length of stay by department. So you bring the department into the rows just like that. Then you drag the LOS into the values. Then because you are actually working on the average length of stay, you have to click on this down arrow, value field settings. Then you also change to average. Just like that, you hit on OK. So this one's basically are the average lengths of stay. So I can just select all of them like that. Then come to this point here and remove the decimal places. Just like that, remove. Then you can just round, but in rounding up, it won't actually get us the true picture. So I'll actually bring the decimal place back. So clearly in this point here, you can actually check that all of them are actually nearly 5 days, because this one is actually 4.7, close to 5, 5.4, just after 5. This one is 4.9, 5.2, 4.9, 4.8, and 5.1. So clearly we can actually say that the average length of stay in the hospital is actually equivalent to 5 days, because all of these are actually very close to 5. So if we actually had one to be 14 days and one to be 3 days, then we could have actually said that when it comes to the length of stay being 14, then we could have actually suggested an improvement in that department, because it could have been the one having the highest length of stay. So the one with the highest length of stay actually means that there should be some improvement inside the department. But when the length of stay is actually 5, 4, 3, something like that, then it actually means that the department is actually doing fairly good. At this point, it will also be very important if we actually generate the average length of stay for every disease. So what you'll have to do is to drag out the department and drag in the diagnosis, because it's actually the diagnosis column which actually has the diseases. So you can actually check that we have the diseases running from anemia all the way to UTI, and the average length of stay is actually this one here. So select like that. Then in this point, I can actually reduce to 1 decimal place, just like that. It's actually done. So clearly you can check that they are almost the same. There's no big difference. All these are very close to 5 days. So the average length of stay for all the patients admitted because of these diseases is actually equivalent to 5 days. So if a patient is actually admitted because of anemia, then the average length of stay is very close to 4.9, which is actually approximately 5 days. In this point, I want us to check on the treatment analysis. So when it comes to the treatment analysis, we will actually start with the doctor's overload. So what you have to do is to get ourselves into the treatments table here, and we have to drag the doctor into the rows so that we can actually obtain the names for the doctors. So we have Dr. Akinyi, Dr. Chebet, Dr. Kamau, Dr. Mutua, Dr. Mwangi, Dr. Omondi, and finally Dr. Wanjiku. So 1, 2, 3, 4, 5, 6, 7. So we have 7 doctors. So what we'll actually do in this point is to track the treatment ID into the values so that you can actually count the treatment IDs. So we will actually be having a count of the treatment IDs. So drag the treatment ID into the values just like that, and we'll actually have the count. So the number of patients treated by Akinyi is actually equivalent to 394, because this is actually the treatment ID. So the number of patients treated by Akinyi is 394. The number of patients treated by Chebet is actually 356. We can actually rank this. So right click, then we actually sort from the largest to the smallest. So clearly we can actually check that Dr. Akinyi is actually having the highest workload, which is actually 394 patients, while Dr. Mwangi is actually having the least workload of 320 patients. So that's all about the doctor's workload. And this one can actually be very meaningful because it will actually help you identify the doctors who are actually overworked. In this point here, you can actually check that Dr. Akinyi is actually overworked because 394 is actually too high. You can actually check that the second one is actually 364. So there's actually a difference of 30 treatments. So maybe some balancing will actually be done on Dr. Akinyi so that she can actually feel relieved, because we have the ones like Dr. Mwangi here actually taking less patients. So we can actually do some balancing here so that at least each of the doctors can actually be taking something like 360 patients, 350, 360. So that's it. I would also want us to check on the most common procedures by department. So when it comes to the most common procedures by the department, we'll have to remove that report first. So most common procedures by the department. So what you can actually do in this point is to drag the department into the rows. So first of all, identify the department. You can actually check that the department is actually here. It's actually inside the admissions table. So you drag the department into the rows, just like that. So these ones are actually our departments. And inside these departments, we actually have different procedures. So we have a different procedure, let's say procedure A, procedure B, procedure C, procedure D. So we can actually have the procedures inside the columns. So click inside the report again and go down there to where we have the procedures and drag the procedure into the columns, just like that. So we can, now you can actually check that you have the blood transfusion here, dialysis, therapy, lab test, medication, physiotherapy, surgery, ultrasound, x-ray. So what you have to do in this point, because you would actually want to have the count for these procedures, these ones are actually the procedures. So we have to fill the accounts on these parts here. So we'll be having the count of blood transfusion when it comes to cardiology, the count of dialysis when it comes to cardiology, count of blood transfusion when it comes to surgery, something like that. So we'll have the count of procedures inside different departments, or the count of procedures by department. So you drag the procedures into the values. So count of procedures inside these different departments, or the count of procedures by department. So you can actually check that in cardiology, we had 48 cases of blood transfusion, 52 cases of dialysis, 40 cases of therapy, that is in cardiology. In cardiology, we had 47 cases of lab test. In cardiology, we had 38 cases of medication. In cardiology, we had 38 cases of physiotherapy. In cardiology, we had 34 cases of surgery. In cardiology, we had 40 cases of ultrasound. And finally, in cardiology, we had 36 cases of x-ray. So if you actually sum all these different procedures, you will actually identify that in the cardiology department, the total number of procedures done was actually equivalent to 373. In the emergency department, the total number of procedures were actually 372. General medicine department, the total number of procedures was actually 351. In the obstetrics department, the total number of procedures is actually 327. In the orthopedics department, the total number of procedures is actually 377. In the pediatrics department, the total number of procedures is actually 359. And finally, in the surgery department, the total number of procedures is actually 341. So that's how you can actually identify the different types of procedures by departments and their accounts. So this one basically will actually help you to identify the most common procedures when it comes to these different departments. So these ones are basically our departments, and you can actually check that the most common one here is actually, or the highest one here is actually 52. So when it comes to cardiology, the most common procedure is actually dialysis. When it comes to emergency, you have to compare all this, and when it comes to emergency, you can clearly check that we have the highest being 49. So in the emergency department, medication is actually the most common procedure. When it comes to the general medicine department, let's also compare these numbers here. You can clearly check that 52 is actually the highest number. So we can clearly say that lab test is the most common procedure when it comes to general medicine department. In the obstetrics department, we can also compare all these numbers here. So from 42 all the way to 39, and you can clearly check that 43 is actually the highest. So surgery is actually the most common procedure when it comes to obstetrics department. In the orthopedics department, we can also compare all these values, and clearly you can check that 53 is actually the highest. So medication is actually the most common procedure when it comes to orthopedics department. In the pediatrics department, let's also consider all these numbers here. So from 49 all the way to 42, clearly you can check that 49 is actually the highest number. So blood transfusion is actually the most common procedure inside the pediatrics department. In the surgery department, you can see that 47 is actually the highest number. So lab test is actually the most common procedure when it actually comes to the surgery department. So the most common procedures will actually help you when it comes to recruiting the new doctors. Because in this case here for the surgery, you can clearly check that given that 47, which is actually the lab test procedure, is actually the highest, then it actually means that if you have to add a doctor when it comes to the surgery department, then probably it will be a doctor who will actually be specializing in the lab testing. Generally, we can actually conclude that the most common procedure in the hospital is actually lab test, because we have a count of 319. So 319 patients going for the lab test. And then when it comes to the blood transfusion, we actually have 303. So this one will actually be the second one. So the most common one in the hospital, that is generally the most common procedure in the hospital, is actually the lab test. So if a doctor is actually supposed to be added, then it can be a doctor who will actually be specializing in the lab test, because that's actually the most common procedure in the hospital. So we can also check count of procedures by the diagnosis. That's actually by the diseases, because this is basically by the departments. So we have to drag out the department and drag in the diagnosis. So you can actually check that when it comes to anemia, the most common procedure is actually blood transfusion. When it comes to anemia, the most common procedure is therapy, which is actually 30 cases. When it comes to appendicitis, the most common procedure in this point, that is the highest number here, is actually that one. So the most common procedure when it comes to appendicitis, which is actually a disease, is actually the X-ray. When it comes to arthritis, the most common procedure is lab test, because we have 39 cases here. When it comes to COVID-19, the most common procedure is actually blood transfusion, because we have 28 cases. When it comes to diabetes mellitus, the most common procedure is actually physiotherapy, because we basically do have that 6 cases. When it comes to fracture, the most common procedure here is the X-ray, because we have the most cases being 28. When it comes to gastritis, the most common procedure here is blood transfusion. We have 25 cases. For the heart failure, the most common procedure is medication. We have 39 cases. When it comes to hypertension, the most common procedure is for therapy. When it comes to malaria, the most common procedure is blood transfusion. When it comes to pneumonia, the most common procedure is the lab test. So we have 27 cases. So that's it. And finally, when it comes to UTI, the most common procedure is basically equivalent to blood transfusion, because we have a whopping 36 cases. So that's basically how you can do the different analysis. And this one will also help you in assigning the new doctors, because you will have to consider the highest or the most common procedures when it comes to these different diagnoses. In this point, I want us to check on the laboratory analysis. So when it comes to the laboratory analysis, we will actually be checking on the lab test. So for the most common test type, we'll actually drag the test type into the rows like that. Now you can actually check that I do have the test types here, but I do not actually have the count of these test types. Like for example, how many times do we actually do a lab test on blood glucose? How many times for cholesterol? How many times for creatinine? How many times for CRP? How many times for hemoglobin? How many times for malaria test, platelets, potassium, sodium, and white blood cells? So to obtain the count of the test types, we have to drag the same test types into the values. So basically, we'll actually obtain the count. And I actually told you that whenever we actually drag an item, which is a text, into the values, then basically we'll be obtaining the count. But if we actually drag an item or a column, which is actually containing the numerical values, then basically we'll obtain sum. So sum for the numerical values, but for the text, we'll always obtain the count. So in this part here, allow me to actually right click. After right clicking, I'll get myself to sort, then sort from the largest to the smallest. So in this point here for sodium, you can actually check that it has the highest test of 531 cholesterol, 524 test, CRP 513 test, potassium 512 test, platelets 503 test, malaria test 501 test, creatinine 489 test, blood glucose 485 test, and white blood cells 471 test, hemoglobin 471 test. So you can actually check that the highest test is actually for sodium, which is actually 531 test, and this one here is actually 471 test. So in this point here, you can actually check that the hospital, which is actually top care hospital, has to actually stack the equipments necessary for sodium test. That is it, because sodium test is actually the leading in this hospital with 531 tests. So there should actually be adequate equipments. Now, in this point, I would also want us to check on this test per age group. So in this point here, yes, we are actually doing 531 tests, but how many of these actually belong to the adults? How many of these actually belong to the children? How many of these belong to the seniors? And how many of these belong to the young adults? So in that point, we will actually be having the adults on this part, young adults, seniors, and the children. That is in different columns so that we can actually obtain the breakdown. So what you'll actually do in that point is to drag the age group, that is actually in the patients group, drag the age group into the columns, and basically this is what you actually get. So you are basically getting the breakdown, but the numbers are still what you actually had. So this is actually the breakdown, but we have 531 all the way to 471. Those are the numbers which we actually had. So in this point here, you can actually check that when it comes to the test for sodium, it's actually the adults who are actually leading with 258 tests, or 258 patients actually tested for that case. When it comes to something like platelets, you can actually check that the category leading here, or the age group which is actually leading, is also the adults with 243 tests. On this part, you can also check that the category leading is also the adults with 218 test. So we can actually say that in this top care hospital, most of the patients who actually go to the lab test are actually the adults. You can actually check that it's 2293. So they actually lead by a mile. The one which is actually following is actually 1275. So you can actually check that it's almost double. Everything is actually done. So I want us to do the advanced cross analysis. So we are going to try to understand our data deeply. So what you can actually do in this point is to obtain the average cost versus the length of stay. So basically you can actually drag the length of stay into the rows like that. So remember, the length of stay is actually the discharge date minus the admission date. So we actually add 1 day, 2 days, 3, all the way to 15 days. Now I would actually want us to drag the cost into the average, and basically because cost is actually a numerical column, then we'll actually obtain sum by default. Now when it is like this, it's actually telling us a different thing. So in this point here, for all the patients who actually were admitted for 1 day, the total cost was actually equivalent to this one here. So allow me to select all this like that, get myself to the home tab there. Then on this part, I'll actually hit this 1000 separator. So for all the patients who were actually admitted for 1 day, then the total amount that they actually paid is actually equivalent to 2,247,437. For patients who are actually admitted for 2 days, the total amount they actually paid is 5,510,201. For patients who were actually admitted for 3 days, the total amount that they actually paid is approximately 7.5 million. For patients who were actually admitted for 4 days, the total amount they actually paid is approximately 9 million. For patients who were actually admitted for 5 days, the approximate amount that they actually paid is 7.8 million. So basically, that's how you can actually analyze this data here. So in this point, I would actually want us to check the average amount that was paid by one patient. So I want us now to come to this point here, that is day 1 all the way to day 15. We will be obtaining the average amount paid by patients. For those patients who were actually admitted for 1 day, what was the average amount that each patient paid? And on this point too, for patients who were actually admitted for 2 days, what was the average amount that each patient actually paid? So that's actually very possible. So we have to come to this down arrow here. You click on it, value field settings. Then we actually hit on the average. Then we hit on, now you can actually check up there on the custom name. You can actually check that we have the average of cost. Remember, you can always change this, but let's just hit OK. So basically this is it. Now you can actually check that this is the average cost for all the patients who are actually admitted for 1 day. This is also the average cost for the patients who are actually admitted for 2 days. This is also the average cost for the patients who are admitted for 3 days. Average cost for the patients who are actually admitted for 4 days. Now you can actually check that for day 1, it's actually less. But for day 15, it's actually more. Unlike what we actually had before for sum of cost. So I can actually drag cost again there so that you can actually compare the two. Now you can actually check that for day 1, you can actually check that the sum of cost is actually higher, but for day 15, the cost is actually 66,095. So you can actually check that this one is actually the total amount paid by patients who are actually admitted for 1 day. That is it. That's for the sum of cost. Now, if 10 patients actually paid this amount, so what you are actually going to say is the total amount that the patients actually paid divided by that 10, then you will actually obtain the average of cost. So this actually means that we had a lot of patients actually being admitted for 1 day, because for this number to be actually equivalent to this one here when it comes to average, then it actually means that it must have been divided by a big number. So let's also check on the count of cost. So we'll actually drag the cost into the values again. But in this point, we are actually going to obtain the count. So hit on the down arrow there, value field settings. Then I hit on the count. Then, okay. Now you can actually check that this is now the count of the patients. So this is basically the count of the patients. Why? Because this is actually the total amount that the patients actually paid. That is the patients who were actually admitted for 1 day. So the total amount that the patients who were actually admitted for 1 day paid is actually equivalent to this one here. And the average of the cost, that is the total amount that these patients actually paid divided by the number of those patients. So if you divide by the number of those patients, you actually obtain this one here, which is actually the average. So we actually went to obtain the count of patients. So this is basically the count of the patients. So in obtaining the count of the patients, now we have the number of patients who are actually admitted for 1 day is actually equivalent to 49. So allow me to actually cut the decimal places because we do not have 1 point something of a person. So this one here, which is actually the sum of cost divided by 49, will actually get you the average cost. That is basic mathematics. Sum divided by total will actually get you the average. So when it comes to this point here, for the patients who were actually admitted for 15 days, we have actually said that the total amount they actually paid is 66,095, and the average is actually 66,095. So that actually means we add one patient, and that's what we actually do up here. That's it when it actually comes to the average of cost versus the length of days. So let's also see if some ethnic groups are actually more prone to certain diseases. What we have to do is to drag the ethnicity. We can drag the ethnicity into the columns like that. Yes. Then we actually drag the diagnosis, because diagnosis is actually the one containing the diseases. Drag the diagnosis into the rows, just like that. And now you can actually check that I have Kalenjins. Then on this point, I also do have the campus. Allow me to actually expand this like that. On this other end, I have the Kikuyus. On this other end, I have the Luyas. And on this other end, I have the Luos. On this part, I have others. Yes. Now, in this part, I want us to obtain the count of these diseases. So when it comes to anemia, how many persons were actually reported who actually belong to the Kalenjin ethnic group? How about the Kamba ethnic group? That is anemia still. So for anemia again, how many for Kikuyu ethnic group? So we have to drag the diagnosis into the values so that it can obtain for us the count of diagnosis. Just like that. So basically, you can actually check that when it comes to anemia, the other ethnic groups, we can't actually say that the other ethnic groups are actually more prone to diseases, because this group for others might actually be a group of 5 people who are all sharing that one. So we can confidently say that most of the people who are actually come to the hospital for anemia treatment are the Kalenjins. Yep, that's it. And on this part too, we can also say that most of the people who are actually come to the hospital, we can say the Luos, because these others is actually a combination of several types. So we can actually say that majority of the people who are actually come to the hospital for appendicitis treatment are the lowest. And the majority of them who are actually coming again for arthritis treatment are the lowest. Majority of them who are also come to the hospital for COVID-19 treatment are the Kikuyus. Majority of the patients come to the hospital for diabetes mellitus treatment are actually, we can confirm that it's actually the lowest, yes. And on this part too, majority of them who are actually come to the hospital for treatment, that's for fractured treatment, are actually the Kalenjins. And majority of the patients come to the hospital again for gastritis treatment are actually the Kalenjins again. Majority of them who are also come to the hospital for heart failure treatment are the Luos. Majority of them who are also come to the hospital for hypertension treatment are the Kalenjins. Majority of them who actually come to the hospital for malaria treatment are actually the Kalenjins. For pneumonia treatment, they are actually the Kalenjins again. And for UTI treatment, they are actually, we can say others, but we can also confidently say it's actually the Luyas. So we have said Kalenjins a couple of times and Luos a couple of times. So majority of the patients who actually come to this top tier hospital are actually the Kalenjins and also the Luos. In this point, I want us to actually build a responsive dashboard inside pivot tables. So first of all, we will actually have to pick our items. Let's say, for example, the first one will be the top 5 diagnoses by volume. So for the top 5 diagnoses by volume, what we'll actually do is to drag the diagnosis into the rows like that. Then we'll actually drag the count of diagnoses so that you can actually know the volume. So in this point, you can actually check that we have from anemia all the way to UTI. So I would actually want us to rank, that is from the first one, that is from the largest to the smallest. But we can still do the filtering so that it can actually sort automatically. So we actually click on this column here because that's where we actually do have the filtering button. Then we actually right click. After right clicking, we have what you call filter. Hit on the filter there. Then we have top 10. In this point, we would actually want to obtain the top 5 diagnosis by volume. So by count of diagnosis. Hit OK there. And now you can actually check that I have 113, 113, 108, 106, 107. So you can actually check that the filtering button there has actually changed. So this one is basically the first one, and this is, we can have it there. This is the top 5 diagnosis by volume. Just like that, and it's actually done. So the second one will actually be top 3 revenue by department. Now, the problem is, how will we insert a different pivot table so that you can actually erase this one here? So you have to get yourself into the insert tab there. Then you have what you call the tables group. Click on pivot table. Then insert on the existing sheet. Then we are using this workbook's data model. So we are using the data model that actually exists. So we are just inserting a pivot table, but the model will actually be the one which is actually existing. So use this workbook's data model. It has actually been selected automatically. Then existing worksheet, it's actually this cell here, which is actually D3, which is actually okay. And you'll actually check that if I click inside the pivot table there, this pivot table fields also appear. The same case when I actually select a cell there inside the first pivot table report. So that's how you can actually insert a pivot table so that it can actually connect to the same data model. So in this point here, we would actually want to obtain the top 3 departments by revenue. Top 3 departments by revenue. So what you have to do is to drag the departments into the rows. So drag the department into the rows and drag the cost into the values. So that in this point here, we have to click on a cell on this row here because this is where we have the filter button. Then you actually right click. After right clicking, we have filter. Then top 10, you click on top 10 so that you can actually edit. So we actually want top 3. So you reduce to 3, then by the sum of cost, which is actually okay. Hit okay there. So we actually have this 3. So basically, you can actually rank them. So allow me to actually rank so that it can become very simple. Sort from the largest to the smallest. And that's it. On this point too, you can actually sort from the largest to the smallest. So basically, that's how you can obtain top 3 departments by revenue. So merge and center top 3 dip by revenue. Just like that, hit enter on the keyboard. Now, the third one will actually be the readmission rate by age group. So we would actually want to check the total number of persons who have actually been readmitted based on the age groups. So that's actually very simple. So we have to insert a different pivot table report. So get yourself into insert tab there, tables group, pivot table, that's it. So use this workbook's data model. It has actually been picked for us automatically. Existing worksheet, which is actually okay. It will be G2. Then I just have to hit on okay here. Readmission rate by age group. So for the readmission rate by age group, what you have to do is to drag the age group into the rows. So first of all, drag the age group into the rows. So readmission rate by age group. So you drag the age group into the rows, then you drag the admission, that is the readmission within 30 days, the count into the values. So count of readmission within 30 days into the values so that you can actually obtain the sum of readmission. Allow me to actually bring this down here. Yes, like that. So you can actually check that the total number of adults who are actually readmitted within the 30 days is actually 71. Total number of children who are actually readmitted within 30 days is actually 9. Total number of seniors readmitted is 22. Total number of young adults readmitted within 30 days is actually equivalent to 41. So what I have to do there is to merge and center and say readmission rate by age group. Just like that, hit enter on the keyboard. So that's all there. So in this case, I would also want us to obtain the top 4 doctors by patient volume. So top 4 doctors by patient volume. So insert pivot table there. Then it's actually okay there. I just have to hit on okay. Then we just have to come to the treatment here, drag the doctor into the rows so that we can obtain the doctors there. Then in this point here, we have to drag the admission ID into the values so that we can actually obtain the count of admission ID, because every admission ID actually represents a patient. So we have Akinyi here, 394 patients, Dr. Chipet, 356 patients, Dr. Kamau, 363 patients, Dr. Mutua, 354 patients, Dr. Mwangi, 320 patients, Dr. Omondi, 364 patients, Dr. Wanjiko, 349 patients. But we actually wanted top 4. So I click on this column here because this is basically where we have the filter button there. Then right click. Then we have filter there. I click on the filter top 10. Then I actually reduce it to top 4. Then after top 4, I just have to hit on okay. That's it. So these ones are basically the top 4 doctors. I can just click on it like that, one of the cells there, right click so that I can actually sort from the largest to the smallest. So sort from the largest to the smallest. So in this point, you can actually indicate that this is actually the top 4 doctors by patient volume. Just like that. And finally, I would also want us to check on the distribution for the gender. So it's actually very possible because we'll just have to drag the gender and the admission ID. So insert, then pivot table there, then use this workbook's data model, which is actually okay. I hit on okay there. Then what you have to do is to drag the gender into the rows, just like that. Then we have to drag the count of admission ID. So we can just come to the treatments there and pick admission ID. So it will actually have a count of admission ID. And you can actually check that for the females, we have a total of 13 or 3 patients who have actually visited Top Care Hospital. And for the males, we have a total number of 1197 patients who have actually visited Top Care Hospital. The total number of patients is actually equivalent to 2500. And lastly, we can also obtain the top 3 ethnic groups visiting the hospital. So first of all, allow me to actually get a title for this one here. That is gender distribution. Patient gender distribution. So in this point, we can also obtain the top 3 ethnic groups visiting the hospital. So in this point, I would also want us to obtain the top 3 ethnic groups visiting the hospital. So for that one, we'll actually hit the insert tab there. Then we go to pivot table. Then I just have to hit on OK. So top 3 ethnic groups visiting the hospital. So come to this point here for the patients, because that's where we actually have the ethnicity column. Drag it into the rows like that. Then on this point, we have to drag the admission ID into the values, just like that. And we have the total number of patients for these respective ethnic groups. So what you have to do is click on one of the items inside the ethnic groups, like Kikuyu in my case, right click, then I hit on filter there, top 10, then I actually have to obtain top 3 only. So 3 like that, then based on the count of admission ID, which is actually based on the count of number of patients. Hit on OK there, then that's all. And one of the most important item too in this point is us to obtain the top 5 diagnosis by revenue. It's actually very possible. So for the top 5 diagnosis by revenue, first of all, we have to obtain a title for this. So we'll actually call top 3 ethnic groups by volume. At this point, I would also want us to obtain the top 5 most expensive diseases to actually treat in this hospital. So that's actually very possible. I hit on the insert tab there, then pivot table, then I just have to hit on OK. So the top 5 most expensive diseases to treat in this hospital. So what we'll actually do is to drag the diagnosis into the rows, because the diagnosis column actually contains the diseases. Then we actually have to obtain the average cost of treating these diseases. So we have to drag the cost into the values. Then we actually obtain the average cost of treating the diseases, so that you can actually understand the most expensive ones and the ones which are actually cheap. So in this point, you can actually check that these ones are actually the prices. I have to remove the decimal places. So I get to the home tab there and click on decrease the decimal number, just like that. And that's all. Now, because we actually wanted to obtain the top 5 most expensive diseases to actually treat in the hospital, already I have the average cost, that is the price of actually treating each disease. So what you actually do is to right click on this part again. After right clicking, what you actually do is to get yourself into the filter there, top 10. Then I actually reduce that top 10 to top 5. Then I just have to hit on OK. So I have my top 5 there. So remember, this is what we actually call the top 5. Let's actually have a title there. Top 5 diagnosis by revenue. Just like that. So that's actually done. So we have up to 7 reports. So this is actually report number 1, report number 2, number 3, number 4, number 5, number 6, and number 7. We might also want to insert pivot table report for the revenue distribution by insurance type, which is also a very important item. So we can just get ourselves into the insert tab there, pivot table, then we just have to hit on OK. So in this point, we have to get into the admissions there. Then for the insurance type, I drag it into the rows. Then I actually drag the cost into the values, just like that. And that's all. So we have cash, NHIF, others, and then private insurance. So in this part here, allow me now to actually insert a slicer. So for the slicer, what you have to do is to get ourselves into the insert tab. It's actually very simple. Filters group, then hit on the slicer. So in this point here, we are actually using the data model. We have the connections there and data model. So you hit on the data model. It will actually tell you that tables in the workbook data model, we have 4 tables, which is also fine. Open. Then it will actually ask you, you are actually creating a slicer based on what? In my case, I'd actually base it on diagnosis. The other item is actually the department, and I will also base it on the insurance type. That's it. I don't know if we have another item down here. We might also base it on the gender, which is fine. And we might also base it on the doctor. So that's a total of about 5. This is 1. That's 2 for the gender. Then 3 for insurance type. Diagnosis is 4. 5 is actually the department. So that's it. And the moment I hit OK here, I will actually be having 5 different slices because I've actually selected 5 different items from our tables. So hit OK there. Wait. Fine. That's all. So have it up here. Then this one too, have it up there. Then this one, allow me to have it down here. This one, I can have it on this case. Then this one, I can have it here. Yes. So I think that's well. So allow me to actually reduce the size for this like that. I can also reduce the size for, that's actually okay. No problem with that. I can actually reduce this one here so that I can accommodate the other one on this space. Yes. So I still have to reduce it like that so that this one can be accommodated just like that. So basically I have 5 slices and that's all. Now, I would actually want us to come up with the visualization for the readmission rate by age group. We can actually use a pie chart here. So I'll actually click on the report, get myself into the pivot table analyze tab, pivot chart, then I hit on the pie chart there. Then I just have to hit on OK. That's all. So I'll actually drag this down so that you can have it to be our visual number 3. So I can have it here. Yeah, that's okay. Number 4, let's actually check on the visual number 4. So scroll up there. You can actually check that we are seeing the top 4 doctors by patient volume. So in this part, we can actually use different item. Let's actually try to see the kind of a pivot chart that we can use there. So you can actually check that we have all these items. So allow me to actually use a bar chart because we actually haven't used it. So I've actually clicked on the bar chart there. Then you just have to hit on OK. So drag this down like that. Bring it down again. Then bring it down. And then you just have to arrange it on this part, just like that. So those are 4 visuals. And let's also go into the next one. So let's actually scroll up there. So number 5 is actually the patient gender distribution. So for this one, you'll actually use the column chart because there are actually 2 items. So get into the pivot table analyze tab there. Then on this part, you have the pivot chart. Then column chart is actually selected in our case. That's by default. Then I just have to hit on OK, just like that. And we just have to bring it down. So scroll down again. We can just have it to be on this part here so that it can be our item number 3, but to the right, just like that. And that's all. Let's also go to the next item, which is actually top 3 ethnic groups by volume. So get yourself into the pivot table analyze tab, pivot chart there. Then in this part, we'll actually be using the area chart. So we actually click on the area chart like that, and this is it. And just have to hit on OK. So that's actually the area chart. And allow me to actually drag it down again on this part. Then I'll just have to come down to this point here and align it there, just like that. So we have 6 items so far. That is 6 visuals. So what you actually have to do is to zoom out. So this one is the first one, second one, third one, fourth one, fifth one, and sixth one. So we just have to bring the remaining ones. I think the remaining ones are actually about, because we have actually done for the ethnic groups. So the remaining ones are actually 2. So the 7th one is actually the top 5 diagnoses by revenue. So we have diabetes mellitus, fracture, gastritis, malaria, and UTI. This is actually our report. So this is actually the average of cost. We can actually break down this cost based on gender. Yes, we can actually do that. So what you have to do first is to drag this pivot table into this point, drag the gender into the columns like that, and that's it. Now you can actually check that for the diabetes mellitus, the average cost, that is for the females, is actually 44,440, and for the males is actually 51,509, and the average of these two is actually equivalent to 47,200. So I would actually want us to make the changes in this report so that we can actually have the top 5 diagnoses to treat. So for the top 5 diagnoses to treat, what we'll actually do is to drag the diagnosis into the rows like that. And after dragging it into the rows, we will actually drag the cost into the values. So drag the cost into the values like that. But because you are actually checking on the top 5 diagnosis to treat, then it actually means that you would want to check on the average cost of treatment. That is the cost of treating a patient. So what we'll do is to obtain the average of cost. So value field settings there, then average, then hit on OK. This is it basically, and allow me to actually select all of this like that. Then come to this point here, which is actually the home tab. Then in the home tab there, we have reducing the decimal places. I can reduce all of them so that we can actually have the whole numbers. So in this part, allow me to actually clear the filtering here. So I'll click on it like that, then clear the filtering. So you can actually check that I have all the diseases up to the last item, which is basically the UTI. So it's somewhere down here. We have UTI, pneumonia, malaria, hypertension, heart failure, gastritis, fracture, diabetes mellitus, COVID-19, arthritis, appendicitis, and anemia. But we actually wanted to obtain the top 5 expensive. So we are basically filtering. That's why we have to click inside the item there, which is actually one of the diseases. Then right click. Then in this point here, we have filter. Then you have to come to top 10. Then we actually say the top 5 expensive diseases to actually treat. So items by average of cost. So we are basing the top 5 on the average of cost. So okay, there, and these ones are actually the most expensive. So I can actually click on the value, one of the values there, right click, so that you can actually have this sorted in the largest to the smallest. So the most expensive disease to actually treat in this hospital is actually the fracture, because the average of cost is actually 51.134k, which is basically 51,134. And when it comes to the top 5, the number 5 will actually be the UTI, and the average of treatment is actually 47,151. This is actually the average of treatment, the average cost of treating a patient suffering from the UTI. Remember, all these costs are actually in the Kenya shillings. So we have the top 5 expensive diagnosis or diseases to actually treat. Then in this point, this is basically okay. This is for the insurance, and I will say this is fine. So that's actually done there. So for this case here, we'll basically use a column chart. So you actually have to click inside this report. Then after clicking inside the report, you get yourself into the pivot table analyze tab. Then you have the tools group. Then you click on the pivot chart there. Then you click on this column chart. So this is basically how it will actually look like. So just like that, and you actually hit on OK down here. Now you can actually check it on this part here. So we have the top 5 diagnoses to treat, and you can check that we have a column chart there, which is basically fine. So top 5 diagnoses to treat, that is the most expensive diseases, top 5 most expensive diseases to actually treat in this hospital. So clearly you can check that the fracture has the longest column, meaning that it's the most expensive to treat in this hospital. So in this case, I would also want us to visualize this report here. So you click inside the report, get yourself into the pivot table analyze tab there. Then click on the pivot chart. Then on this part here, we have what you call the pie chart, and you basically have to click on the donut chart. Click on the donut chart there, and that's basically what we'll actually get. Hit on OK, and this is it. So allow me to actually drag it down there, and this is it. Now you can check that we have cash, NHIF, others, and the private insurance. So we can have that title to be revenue distribution by insurance type, just like that, and that's done there. So we have this one here, which is basically the donut chart. You can actually check that the longest section is actually belonging to the NHIF. So you can just hover your mouse there and you'll actually check that the category is actually NHIF and the value is actually 25,342,307 Kenyan shillings. And the smallest section is actually this one here, which is basically for the others. That's the other insurances, and the value is actually 4,612,632. There's a small adjustment here, which is basically the top 5 revenue by diagnosis and age group. So top 5 revenue by diagnosis and the age group. You actually drag the diagnosis into the rows, click on it like that, then get yourself into the pivot table analyze tab, activate the field list. So you get yourself into the report, drag the diagnosis into the rows. You can actually check that the diagnoses are actually inside the rows, and the cost, you actually drag that into the values. So sum of cost into the values, that's you drag the cost into the values, and because it's actually a numerical column, it will obtain the sum automatically. So we are actually breaking it down based on the age group. So you drag the age group into the columns so that we can now have the adult in this column, the child in that column, senior in that column, and the young adult in the other column. So we have a breakdown. But if you actually add this one for the adult to this one for the child to this for the senior to this for the young adult, basically you'll actually get 4736813. So that's actually the grand total. So in such a case, you can actually use stacked column chart. A stacked column chart is a column chart, but you have actually broken it down further. So that's it. So you just get yourself into the pivot table analyze tab there, get yourself into the pivot chart there. Then inside the pivot chart, you actually use a column chart. So what you are actually seeing here is what we call a clustered column chart. Yes, for hypertension, we have actually been shown that the blue column is basically for the adults. You can actually check on the key, which is somewhere here, this one here. So this orange one is basically for the children. Then we have the gray one for the seniors. Then we have the yellow one for the young adults. So this is okay. Again, it's actually working fine. So this is basically a clustered, but in my case, I actually wanted a stacked. So this is basically what you call a stacked. So as you can see, for the hypertension, it has actually been broken down further. So the column is actually one, but there's a section in that column which is actually representing the adults, which is actually the blue one. The orange one is basically representing the children. Then we have the gray one representing the seniors, and the yellow one representing the young adults. So what you have to do is to hit on OK down here. Then you actually drag it here so that you can now have the top 5 revenue by diagnosis and the age. So what you'll actually do in this point, because you'll actually realize that we had a lot of slicers. So if I actually click on a slicer there, let's say for example this one here for Dr. Akinyi, you'll actually check that it's not actually responding. Yes, there's no response actually. So for the obstetrics, you can actually check again. Orthopedics, there's no response here. For the surgery, you can also check that there's no response. So what we can actually do in this point here is to clear all these slicers and actually create one slicer which will be connecting all these reports. So instead of us actually having multiple slicers, we can just have one slicer which will actually be connecting all these reports. So click on the filter button there. Then I can actually click on it like that. I can remove that. Click on this one again, remove it. Click on this point, remove. Click on this one again, I will remove again. Click on this point again, I'll remove that. So I want us to insert one slicer which will actually be linking all these reports. And I already showed you how we can actually use one slicer to actually control multiple reports. So that's basically what you actually saw in the pivot table series. So get yourself into the pivot table analyze tab there. Then in that point, we basically have the filter group, then insert slicer. You can also come to this point here, insert tab there. Then inside the filters group, we have what you call the slicer. So click on it like that. Then I would actually want us to insert, we can actually insert, let's actually click on all. So we can basically insert a slicer based on the, we can say the insurance type. So look for the insurance type, which is actually here. I click on it like that. Then I just have to hit on OK. So basically I have a slicer here. If I click on NHIF there, this one is actually responding alone because we had actually clicked on this report when we are creating the slicer. So this one will actually be the one responding. Click on other. You can actually check that it's the only one responding. All the others are actually dormant. Click on the private insurance. you can actually check that it's the only one responding. So I want us to actually link all these reports to this one slicer. So you'll actually have to click on the slicer so that you can basically get the slicer tab there. Then inside the slicer group, we have what you call the report connections. Click on the report connections there. Then you have to select all these reports. So select those ones are 4. Scroll down there again. Select these ones again. These ones are 3. Select them like that. Then go down there. And you can actually check that everything is selected. So I just have to hit on OK, just like that. Now, the moment I actually hit on this slicer, you will actually check that all these reports will actually be responding. So let's actually check. The moment I hit on cash, you can actually check that there are some changes. The moment I hit on NHIF there, you can actually check that it's also responding. Hit on the others, there's a change. Hit on the private insurance, there's basically a change too. So basically that's how you can actually use one slicer, then connect that slicer to all the other reports, and that will be done. So what you can do in this point here, allow me to actually resize this. Click inside this visualization there, then drag this so that I can reduce it like that. Then the next thing is to actually drag this. So I'll actually drag it like that. Come to this point again and drag this. This is it, and I think it's now done. So enlarge it down there. Then I can also reduce the size a bit, just like that. So we basically have a slicer here, and this slicer will actually be controlling this dashboard here. So we can now resize this by zooming it out. Zoom out like that, and you will get something like that. Zoom out again, you will get something like that, and this one is actually better. So we can increase the size a bit so that we can optimize this available space. So increase it once more like that, a little bit, and that's it. So in this point here, you will actually realize that for the insurance types, we actually have 4. That's the cash, the NHIF, the others, and the private insurance. Click on the cash and see how this dashboard actually reacts. So click on the cash there. You can actually check that the dashboard is actually reacting. So the dashboard is actually reacting because the reports were actually responding to the slicer. Remember that the dashboards are actually responding because we actually connected all those reports to this slicer. So click on the NHIF there. You can actually check that there's also a change. Click on the other. You can also check that there's a change. And finally, click on the private insurance. And you can as well check that there's a change. Yes. So for this point here, you will actually check that we have the private insurance. So if you come to this point here for the circle, you will actually check the value there. But if you go to the key, you will also check the insurance type alone. But for the insurance type and the values, you have to hover there inside the ring. So if I click, you can check that it's actually private insurance at the moment. If I click on NHIF, so we basically have the NHIF there. Click again on the cash, and after clicking on the cash, you will also check that we have the cash there, and everything has actually responded. So we have this one is actually the stacked column chart, top 5 revenues by diagnosis and age group. In this point here, we have the column charts, the top 3 departments by revenue. In this point here, we also have a column chart, the patient gender distribution. In this point again, we have a column chart, the top 5 expensive diagnoses to treat. In this point here, we have a ring chart or a donut chart. That's the revenue distribution by the insurance type. In this point here, we have the area chart, the top 3 ethnic groups by volume. On this other end, we also have a bar chart, the top 4 doctors by patient volume. And finally, for the pie chart, we have the readmission rate by age group. So this is basically how you can create a responsive dashboard using the pivot charts. So that's all, and thanks for watching.